Well, good morning. Okay, I want all of you, I'm not going to tell you what the words are, but I want to hear you say good morning in Spanish all at the same time. 1, 2, 3. Ah, okay, now, even better. Welcome in Spanish. 1, 2, 3. Ah, close. Very good. That's the extent of my Spanish, so you won't hear any more Spanish today. Welcome to the Costa del Sol Plugfest Connected Mobility Workshop. This is our 10th OmniAir Plugfest. Can you believe that? We've been doing this over the past 5 years, starting off with a very small event that we weren't sure that we were able to pull off. And now we're starting to do these around the world, Spain and Canada and across the United States, and hopefully next year in Asia. So we'll be very, very excited about that. I wanted to thank everybody for coming such a far way. I look, and all the people I've spoken with this week, people are coming in from Taiwan and Korea and Japan and, of course, the United States and Canada and across Europe. And I think that's just fantastic because we're coming here with a purpose. We're coming together to test and help develop certification programs for these life-saving connected vehicle technologies. And I think that's exciting. And I think the thing that I love the most about OmniAir Plugfests are the fact that it's teamwork. Companies working cooperatively together, trusting, growing, building. I don't know, how many people took an Uber? Did anyone take an Uber this morning? So I happened to get here early and I took an Uber. And they said, what's the address? And I said, Calle Stephen Jobs. And it's really appropriate because we're here in the beautiful technology park of Andalusia, and you could convince yourself that you're in Silicon Valley. It's absolutely stunning place to do business for technology companies. I suspect more than a couple of our companies will look to relocate here at some point. But it also reminds me of one of my favorite Steve Jobs quotes. And he said, great things in business are never done by one person. They are done by teamwork. And I have one of the best teams with OmniAir, and I'd like to thank them for helping to put this together with all of our staff at OmniAir. I'd like to thank our members. I'd like to thank our gracious hosts at DECRA for helping put this together, and I'd also like to thank our sponsors, Qualcomm and Consignia, Integrity Security Services, and Keysight, and many others who've helped us to put together this event because we are united, not just as an organization, but as a team. And I think we're going to do great things this week. Before we get to our other speakers today, I do want to talk just a little bit about OmniAir. We are live streaming this, so we have a number of people around the world to be listening to this broadcast. So if you've heard this before, I suspect there are others that haven't. And in a moment, I'll introduce Thomas Jaeger, who will be our first speaker. So OmniAir is an organization. There's about 90 member companies from around the world. And we're unique in certification bodies in that we have both technology companies, the vendors that develop the radios. We have test labs, test equipment providers, automotive OEMs, Tier 1 suppliers, chipset providers, and uniquely, for a certification body, public sector participation. We have strong participation from infrastructure owner-operators in the tolling space, as well as in state DOTs and cities. And I think having that type of membership gives us a 360-degree view of the very difficult technical challenges that it takes to make this long-promised world of vehicle connectivity a reality. Because as someone who started their career in government affairs and law, we have a lot of pretty words to say that connected vehicles are coming. It's going to save, hundreds of thousands, millions of lives. But behind that, there is a lot of very difficult work that's done by engineers and technicians and people in laboratories sweating and doing the hard, challenging work to make this reality happen. And that's what's happening here this week. And that's what I love about OmniAir. It's a roll-up-your-sleeves type of organization. If you want to make something happen, you roll up your sleeves and you contribute and you do that hard technical work. And then maybe if we're lucky, we get something that's going to change the world. So OmniAir not only is an advocacy organization, but we're about certification. At the end of the day, we want to build trust in these technologies. We want to ensure that the technology deployers, whether those are automotive OEMs or those are infrastructure owner-operators, have devices that they can trust, that they work out of the box, that they interoperate, and that they conform to industry standards and they meet minimum security requirements. And why? Because more trusted technologies means more ubiquitous deployment. It means more market choice. It drives down some of the costs that have been associated with one-off testing for every single deployment project. Instead of having to do testing for every, and acceptance testing in great detail for every project, we test and certify once, which means that that device is trusted in California, it's trusted in Spain, it's trusted in Asia. And we think that's how we help to scale deployment. And that's OmniAir's very specific role. And we do that through a network of authorized test laboratories. We have several in the room today, including TTA and DEKRA, our gracious hosts. We do that through qualifying test equipment to make sure that those test laboratories are using OmniAir qualified equipment. We do that by authorizing field testing sites, just like the one you'll be using today for field testing here. And we do that by certifying devices. All of that comes with that OmniAir symbol that you see behind me. That OmniAir certification mark is that indication of quality. And these are our various certification programs, and we do that both for connected vehicles and for tolling. So in the United States, tolling is RFID in nature. And so we do that for single protocol, and we have a multi-protocol tolling program we're launching later this year. And we also do that for both DSRC as well as C-V2X. And we'll do that for additional technologies as they come along. And our certification is not just the physical layer, it is all the way up the technology stack. And I think that is one of the unique hallmarks of OmniAir certification. I believe it's the only certification body offering that full stack certification for connected vehicles. And this week, we are doing our 10th Plugfest. We have very comprehensive testing that many in this room are actively participating in. We have over a dozen test stations offering bench conformance testing against any number of the standards. We have security certificate exchange tests, location accuracy tests. We're testing use cases, or as we refer to that as applications, such as EEBL and right turn assist. And we want to drive that trust all the way through for the hardware and the software that's involved so that we can have a great user experience at the end of the day. These are a few pictures from our last Plugfest here 3 years ago. When I asked our team, where do you want to go? Where do you want to go back to for OmniAir Plugfest? I asked our members. They said Malaga. Malaga is an absolutely fantastic town. DEKRA has been a really wonderful partner with OmniAir's over the years, and has just one of the absolute best comprehensive lab and field testing facilities for vehicle connectivity and other wireless technologies. So this week we're in very good hands, and I would like to just give a round of applause for DEKRA. Haven't they been great hosts? This is my contact information. And speaking of great hosts, I would like to next introduce Thomas Jäger. And Thomas Jäger is the head of technology and technical service management for DEKRA. He has been one of the leaders in wireless certification technologies, very active in OmniAir, in 5G AA, in 𝗪𝗋𝗄𝗎, in a number of different standards and certification bodies. Throughout the years, he has been tireless in its efforts to help promote testing and certification, tireless in his efforts to help promote OmniAir and what we're about, and just brings a great body of knowledge and expertise, and I think has a really unique perspective on where the industry is headed and should be headed. And so please join me in welcoming Mr. Jäger to the floor.
Thank you very much, Jason, and yeah, a very warm welcome also from my side here in our nice premises in Malaga. I'm really glad to see you all here, and I think it's a great honor for all of us to have you and to serve you and to host you And of course, from my bottom of the heart, I hope that you all have a great time. So I will talk a little bit about why actually also 𝗖𝗂𝘂𝗧 is very much involved in all of this, and how we see this, what is also happening here is very, very important. And of course also how our organization is embedded in this ecosystem, and we help actually in the area of making the world a bit more safer. So coming from our vision of where we are heading to, you can see here, I mean, our vision is we want to be really a global partner for a safe, secure, and sustainable world in the future. And that actually leads into our mission, which helps actually people in the three main areas: on the road, at home, and also at work. And we are here today and this week in order to improve safety, especially on roads. As you know, the environment that we are working in is quite complex. We have a lot of different requirements, areas and sets that need to be satisfied, and that have to match actually the different complex technology layers that we are addressing in our different worlds. So from that perspective, we have developed altogether different measures actually to bring these things together, where conformance, interoperability, performance, security, efficiency, sustainability, these are all elements that play an important role and need to be covered altogether. And dealing with this, and that is actually what is then the certification impact, and Jason already explained it, also with a word of trust, trust and acceptance, actually that is being generated also by certification. Certification is a platform for success, and we have seen this. I mean, I was involved, and I had the pleasure to start digital mobile communication in the 90s, where we developed a certification scheme at that time that really helped to bring the industry together, to bring the whole world together finally. And now we have all the mobile phones in our pockets. And that actually also one of the important factors at that time was really certification. And I think not many people really remember that, but I do, and I know how important it is. And at the end of the day, it really ensures the availability of what we have for the different business fields, if it is B2B or B2C, whatever. I think we have here then the platform for all of this. So it's a super important element that we need to cover. I think our organization is part of it. As Jason explained, I mean, we helped OmniAir already from the beginning to introduce DSRC, and now we are involved in V2X and also in the tolling area. So 𝗖𝗂𝘂𝗧 is an organization, as you know, the headquarters is in Germany, and we are a large organization nowadays, 47,000 people all over the world. And we were coming from industry inspections, automotive inspections, and we have started already many years ago in 2008 to take care, together with some governments also in Europe, especially also Germany, to look into specific aspects of safety. And every year we are issuing safety reports that might be also very interesting for you to read, that you can download for free at our websites, and where we are looking into particular aspects of safety. And these reports have been used now over the time also for governments, especially also in Europe, as references, because we are providing a lot of statistics, a lot of data facts on, you know, where we are with safety and where are further rooms for improvement. And as you can see, we are watching very carefully a lot of stuff like traffic fatalities. And as you can see here, I gave you here just a very small example. This is just for Germany, and we are not have reached our targets yet. So there is still a lot of room for improvement. And I can tell you that in some areas now the fatality figures are ramping up again, and because of specific circumstances. So most recently we are even more far away from actually goals that we have defined in specific countries, but also, for example, in specific regions. Also, the European Commission has set some rates of what they are going to achieve by certain dates. But unfortunately, there's not yet that point achieved. So also a lot of other interesting topics you will find. Also, we recently researched what is the correlation between the gender and also between ages, where different age statistics we have evaluated, and where really fatalities have happened in the area of cars, and especially also now two-wheelers. This is a very high concern now. Also in Central Europe, the number of two-wheeler facilities are really now going through the roof, especially during the pandemic times. A lot of people have changed their mobility behavior. So there is a lot that we need to do. Yeah, and DEKRA, I think we are quite in the middle of this with different service and R&D centers. As you see here in Malaga, we have the R&D center for connected driving especially. Some of you know that we have also a large site in Germany where we do connected automated driving, all kind of stuff for vehicles, full vehicles. So in this combination, especially here in Europe, we drive the activities also towards more safety, and I hope that you can get a little bit of that kind of spirit here during that week. And as I said, I mean, you are warmly invited also to look to our website to see a little bit more of what we provide also as a company. Some people really don't know this. It's sometimes a bit hard to find, and I would say DEKRA is not so good in globally marketing this kind of information in Germany, of course, in Central Europe. This is much better known, but it is unfortunately not so much in the rest of the world. So I'm trying to promote this so that potentially you can also make use of this kind of information, and maybe we can all use it together in order to enhance the safety on roads and for the traffic. So with that, this is actually what I wanted to say, and I again would like to wish you a very nice day here, a successful conference, and of course a lot of success during the whole week. And in case of any questions, of course I'm happy to answer them during the week. I will be around. So once again, thank you very much and welcome again. Thank you.
That was fantastic. That was absolutely fantastic. And if any of you are here at DEKRA for the first time, I know some are just coming to this workshop and have not been part of the testing this week, I would encourage you at 3 o'clock to come over with us for a tour of the testing facilities at DEKRA. They are absolutely world class. You'll also see demonstrations of our testing, be able to walk through the various bench testing that's happening and learn a little bit more about OmniAir certification programs. Also joining us this afternoon will be the mayor of Malaga, who will come over for tours. So be on your best behavior because the mayor will be watching. But before we do that, we have a great couple of panels to get through. We have I asked the stage Mike Brown, Randy Roebuck, Dr. Zhang, Rosario, and Bill McKinley. Please come join us. I'm going to ask Mike to introduce the various panelists, but let me just introduce Mike Brown first. So the first time that we decided to have an OmniAir Plugfest, Mike was the host at Southwest Research Institute in San Antonio, and they did an absolutely fantastic job. And that was really my first experience getting to know Mike, but what I didn't know is Mike has been dedicated to this in this space for the past 25 years. He is an institute engineer with Southwest Research Institute. He's also a leader in the technical space, a leader of the TC204 a working group there. It takes them all over the world in helping to drive harmonization of global standards so that we can have a truly global marketplace. Mike also serves on our board of directors, on our executive committee for OmniAir. I have leaned on Mike's steady leadership over the years. And I also asked Mike to chair our first coordinating council, which is comprised of the technical leaders of OmniAir, the chairs of our working group. So he has just a couple of things on his plate. Please join me in welcoming Mike.
Okay. Thanks, Jason, and thank you so much to all of our panelists. I'm going to start off a little bit. What I asked each one of the panelists to do is give just a few minutes of overview of who they are, rather than just regurgitating bios and reading those. I asked the panelists to talk a little bit about who they are, their organizations, and I think that helps bring perspective to the panel discussion we'll have ensuing after that too. So I'll start off. My name is Mike Brown, Southwest Research Institute. As Jason mentioned, we've been working in this space for about 25 years in intelligent transportation systems, connected and automated vehicles. Been involved with OmniAir for since I can remember that OmniAir started, maybe a couple years after OmniAir started. And we've been really excited to be part of OmniAir. I'm always happy to be back in Malaga, such a beautiful city, but also such a great technology center. It's really fantastic, and I'm really excited about all the panelists that I'm joined by today. If you're not familiar with Southwest Research, we do everything from connected and automated vehicles to the infrastructure systems. And so I'll talk a little bit about some of that and what we do, just a few minutes. We've automated over 25 different platforms to date. It seems to grow every time. We do everything from off-road, one-off type applications to enabling technologies for automated vehicles, perception systems, vehicle localization type systems. And then, of course, communication. How do vehicles communicate with other vehicles? How do they communicate with the infrastructure? So not just on the vehicle side. So we can figure out the communication technology, but the chairs are a challenge still. So not just the vehicle side that we work on also in some of those technologies and communication, but we also work a lot with the infrastructure, especially the infrastructure owner-operators, and in how that relates to OmniAir is really in a lot of the communication from the road operators, from vehicles to the road operators, and then the applications that support that. So I'm hoping we get into some of the discussion about applications because it's something I'm very interested in. We work on applications from the edge, so systems that do things like wrong-way driver detection, detection of pedestrians and warning systems, so video analytics at the edge, to traffic management systems that operate for a region. So if your city or your state has a traffic management system, we develop software that does this. We have an interesting model in that we don't own the software. We develop state-owned software, so we work for public sector entities and develop custom software for them that they can do whatever they want with. And then this works quite well for us. We're involved in over 15 states now in the U.S., supporting them in their custom software development for traffic management systems and deployment. And then these communicate with roadside units, and then ultimately up to cloud-hosted systems, so systems that operate at a region to statewide, to even a broader region like a corridor. We develop cloud-hosted data exchange platforms that can then tie into both the traffic management systems and the edge systems to enable applications. And this all just to say, I think I'm very interested in the discussion around applications and how the communication can help enable the applications, something we're quite interested in. And with that, there's my contact information too. I'm going to go in the order that Burkinda has our slides. And so next up, I'll introduce Bill McKinley from 𝗖ście to give us some opening remarks. Thanks, Bill.
All right. Thank you, Mike, and Good morning from my side, everyone, and welcome again to this lovely facility. My name is Bill McKinley. I work for Keysight Technologies. And I have to say, just to comment on Jason's introduction, this technology park is, I'm from Scotland, and maybe my accent gives it away, but one of the roads, Stephen Jobs, but the road directly before that was James Clerk Maxwell, who, I hope all engineers know, the father of the electromagnetic theory and unification of electromagnetism and you know, the Maxwell's equations that we all struggled with at university. So it's great to be here as well. The one good thing I like about OmniAir is that, there are many things, but one of the main things I like OmniAir is that we're all get our hands dirty. Just as Jason mentioned, last week we're at the 5GA event. And yes, that's pretty high level and a lot of strategies and we'll do this, that, but on the air, it seems to be, this is where the work gets done. We just get on with some problems and try to figure out how we test this stuff because it really needs to be tested. So Keysight, a test equipment manufacturer. I know the screen's a little bit hard to see, but the big news for Keysight is that we merged with a company in Germany called 𝗪𝗔𝗃. And I don't know how well known 𝗪𝗔𝗃 is outside of Europe and Germany in particular, but we've been working with 𝗪𝗔𝗃 for several years now, and we integrate their ITS stack into our equipment. But not only do they have that ITS stack and some pretty cool software, they have a range of products that we call from our traditional Keysight is in the lab. And now we've got some field products that 𝗪𝗔𝗃 have essentially given us to our portfolio. You can see some of them here, and you'll see hopefully some of them in the demos this afternoon. But essentially, we've got products that can help with application development, application platform, such as what we call CarKit. It essentially mimics an HMI on a vehicle, but it's a development platform that OEMs and I guess the tier ones can use to develop, okay, how does this HMI, does the triangle appear in the right way for EEBL, for example? But not only that, we have RSUs and we have a thing called 𝗪𝗡𝗂𝗏, which essentially can emulate ghost vehicles on a test track. So you don't have to have 3, 4, 5, 10 real vehicles all interacting. You can have a device under test or vehicle under test, and you have other simulated vehicles that will interact. So it really enhances our portfolio, and hopefully get a chance to see those as you go up into the test lab. So our let's say traditional Keysight equipment is in the lab. We've got another setup where we are testing with this morning. I think maybe that's we have several software products that indeed carry out the automated test sequences for all the test cases for OmniAir. We were one of the first equipment or companies to get OmniAir qualified test equipment, working with the qualified test labs such as here in DEKRA. So we can automate running through the physical layer and also the upper layer, the protocol test cases. And again, you can see that. But to Mike's point, we're looking at the application space now, and we do have some interesting demos to show on our application, at the application layer, which is the next big thing that we need to nail as far as I'm concerned, I think. But this is the kind of setup that we have, a little bit difficult to see, but essentially we can create scenarios in software. We can create, multiple scenarios all happening. So we'll take an example as EEBL, electronic emergency brake light warning. We create this thing in our software here in Malaga. We have the test track, all simulated environment. We have a kind of automation sequence. We include the GNSS scenario, other vehicles that would take part in it. And then we have a channel emulator where we can emulate fading, antenna profiles or antenna models if you've got some new designs, play it out to the vehicle or the device under test. But importantly, we can feed that back, and so we can timestamp when let's say the triangle appears on the HMI, looking for latencies, and we can and automate the whole thing. So it's hands off. You press run, it just goes. And then finally, we've got this. We're doing a little bit of cybersecurity, and misbehavior detection seems to be a big thing. So we're now got some proof of concept where we can look for bad actors, identify the bad actors, label them on our icons, turn them red, for example. And again, we can make sure that those bad actors are sent to the authorities and could be or should be ignored for any future communications. I'm not going to go through a whole bunch of these slides because we want to get into the meat of the panel session, but hopefully you'll be able to come and see and have a chat with our team up at the test track site later this afternoon. And I'll leave it just there. Okay, thank you very much. I look forward to speaking to you later.
All right, thanks, Bill. That's great. Bill brings such good perspective to the panel. Oh, we got another chair too. Excellent. Okay, we'll keep going in the order. We have the slides. Let's next welcome up Rosario Chaparro-Morales from DECRA to give us an overview of herself and what she's been doing at DECRA. Go ahead, Rosario.
Thank you. We are very excited to have all of you here working together. Again. Okay, then this roundtable is about the worldwide V2X. As you can see here, there are many association and standardization bodies working in different requirements. And for example, OmniAir, GSF, a lot of different organizations. And DECRA is participating actively in all these technical working group. Then we have the acknowledgement of this requirement from the beginning. Okay, then we can classify the requirement in two groups. The first one is regulatory, is the requirement that you have to fulfill to sell your product. And the second one is the industry association requirement. Mainly, they are interoperability, conformance, performance, functional, and cybersecurity requirement for all these type of technologies. Okay, then in DECRA, we can provide most of these testing requirements. For example, we can provide regulatory, conformance, interoperability, performance, and functional. Especially the application testing, that now is the focus of this Plugfest. Okay, then we provide this for different regions, because in each region there are different requirements, different protocols. The requirements are not global in this case. There are different requirements for each region. For example, for Europe, there are some requirements, some regulatory requirements for US, the FCC, and for China too. We can provide here in our facilities, very close to here, the conformance testing and certification testing for both technologies, for V2X, DSRC, and CV2X. You can see here some of our test bench. One of them is the 𝗖cie test system. And we are adding continuously the new requirements that are published by the different organizations. Okay, then regarding the application testing, now in our test track, we are developing different test scenarios using different platforms. We develop our own test scenarios that we can test in a very, very safe way, because we are simulating different elements of the traffic, and only the real car or the real device under test is running in the track. Okay, you can see here the OmniAir test specification with all these applications that now are growing. We are including different applications for America. Also for China, we have the list of B2B and B2I application, and also for Europe that this requirement, these are the release 1, but now 𝗪𝗔𝗄 is working in the release 2 of this basic set of application, including cooperative driving. We are going to, I don't know if we are going to see finally the video, because they say that. I prepare a video, but I don't know if we have time to see it, with some example for China, for US and for Europe about how we are testing application. But I don't know if we can see the video. Yeah? Okay. We are going to see two examples for China. One is B2B, and the other one is B2I. In this case, is you can hear but not see. all these day one applications are now available in different locations of DECRA for the day one application, okay? For CV2X and also for the SRC. You can test the different region or the different region in the same test track. This is an advantage, I think. And now we are working in the development of the day two application, for example, sensor sharing and the cooperative driving application, using the platform that you saw and other platform at the 𝗪cie platform for this day two application. Okay, thank you.
Thank you, Rosario. I think that framed our discussion very well, showing each of the regions and many of the various applications and testing. Next, let's invite up, let me go to next slide. It should be on. Okay, yeah, next let's invite up Dr. Hongjiang Zhang from 𝗪𝗧𝗓𝗓 to give us an update on what he's been doing, introduce himself, and what 𝗪𝗧𝗓 is doing in this area. Thanks, Hongjiang.
Mike, thanks for the introduction. It's very honored to introduce Korean V2X testing status to you. Yes. Frankly, in the last several years, Korea has lots of various CITs and V2X pilot project is undergoing. Actually, frankly speaking, I'd like to tell this status efforts to deploy V2X in real world. Actually, the struggling to deploy the V2X infrastructure in Korea ASAP. Actually, I think many of audience wonder that how many Koreans attend this Plugfest. I think this slide can provide some answers to you. I'm Hong-Jong Jeong from 𝗪𝗧𝗓. 𝗪𝗧𝗓 is a small startup company working based in Korea. So I'd like to introduce our Korean V2X testing status. And there are, I think we can tell you 3 major activities in testing area. The first one, deploying CITS infrastructure in nationwide. And the second, proving the readiness of LTE V2X in the real world. Last, the Korean CITS plug test. Let's start with deploying. Yes. In the left figure, that shows the Korean CITS pilot project, several CITS pilot project. Actually, Korean CITS pilot project is supported by Ministry of Land of Transportation as well as small local government. So you can find several pilot projects. And the red line represent the latest and largest CITS pilot project in Korea is undergoing. Actually, the pilot project covers more than 700 kilometer national highway from the Seoul to Busan. And it will cover 700 kilometers and with more than 500 RSUs. So this project was started end of last year, and end of this year, 500 RSUs will be deployed. It's amazing, I think. And this project, one of the challenging is the RSU coverage testing and quality of service. So before starting this project, we wondered how can manage the quality of the RSU coverage and testing. So in this project, 𝗪𝗧𝗓 involved in this project. We designed the testing system for coverage and coverage testing. as you can see in the figure below, there is a vehicle and the test system, which can measuring the RSU coverage in the real world. So with this system, the end of this year, we will start to test the RSU coverage and the quality of services. And right figures is one of the big event in Korea. Actually, in Korea, as like in US, in Korea also struggling to decide technical. We are struggling to decide the V2X technology between DSRC and LTE-V2X. So from more than 10 years, Wave DSRC has proved in technology or its readiness. But Koreans thought that LTE-V2X is not enough proved in the real world. So in this year, we started up the pilot project to prove the readiness of the LTE-V2X. So in the limited area, we intensively we designed several test cases, including GNSS shade area and tunnel and congested area. So as you can see some figures, there's some test scenarios. The upper one shows the test cases in congested area. We deploying around 20 vehicles with congestion, the V2X test equipment emulating the V2X congesting method. The bottom one provide some figures testing in the tunnel environment. As you know, the LTE V2X has some limitation in GNSS shade area. So in such a case, we define some factors to test, like a packet error rate and latency. We measuring the performance of the LTE V2X OBU as well as RSUs. And the last one, I'd like to introduce some activities, test activities in Korea. The 𝗖cie test plug test hosted by ITS Korea. 2 weeks ago, the Korean 𝗖cie test plug test was held in Korea. So we also ladies also attend the plug test. As you can see in this figure, there are lots of many Korean companies involved in this project, including OBU company, RSU company, SCMS security, and as well as testing company like 𝗲𝗍. And 𝗲𝗍 provide V2V driving test system and congestion generator, as well as application bench test. And in Korean 𝗖cie test plug test covers not only V2V, V2X communication testing, and they are extending the coverage into equal and tolling systems. And thanks to the collaboration with ITS Korea and OmniAir, ITS Korea adopt lots of test cases and test specification from OmniAir. So that's why, and thanks to the OmniAir, we can provide driving test tools, ITS Korea, as well as in several companies. So I introduced that lots of Korean standards are similar with the US standard. So I think many other OmniAir members can have some business opportunity in Korea with minor protocol revisions. I think it's a very good point to you. So in ITS Korea plug test, they are extending some test cases from protocol conformance to the application testing, because in Korea there's actually, as I introduced just a previous slide, there are several 𝗖cie test pilot projects, and in each project define their application scenarios. So in Korea, there's more than 30 applications use cases in the specific test pilot project. So in Korea, in the perspective of application test developer, it's very hard to design and cover all of the application. It's our homework. So we need to design some common platform for covering several applications. So yeah, and that's why I think it is an answer to why many Koreans attend this Plugfest here. So okay, in Korea, I'd like to in this Plugfest, I think we can learn lots of new applications and new standard, and we can find some opportunity to extend our test tools, and we will adopt this new designed application in our plug test in Korean plug test. So we can make business opportunity, and it's our way to survive in V2X test area, like such a small company. Okay, thank you for the listening.
Okay, great. Thanks, Hong-Jung. And last but not least, we have Randy Roebuck. For those that don't know Randy, you're probably in the wrong place. Randy's the one that really makes everything happen and brings this all together. I've had the pleasure of serving with Randy connected vehicle testing for maybe a couple decades almost now, and he's been phenomenal. I don't know if I've known anyone that's probably more dedicated to the success of the technology. Randy, you want to take just a couple minutes? I know most people here absolutely know Randy, but we are live streaming, so maybe Randy, if you want to just take a minute or two and introduce yourself.
Hello, I'm Randy Roebuck. Thank you for coming to Malaga. The second time has been just as good as the first time. As Jason would say, fantastic. And he's always short when he speaks. Of course, I can usually get through a 4-course meal. In Spain, I think I have less than 2 hours to get through. But I think Ryan and Jason set me up here. I sat down here and the chair collapsed. It's not due to the weight, and I ran this morning. So thank you very much. The importance of testing standards and everything, and you all getting here in a cooperative spirit is actually been wonderful. We had the opportunity to participate in a 5GAA session last week, presented a couple sessions, showed off all your test tools at the demo day. We had the 𝗖𝗃 tablet that couldn't be here. We showed the 𝗪cie sniffer, which they brought their whole system this week to test with. We had the weighty sniffer tool that we shown. We had the Keysight North Systems tool. We had the USDOT V2X hub, which now they're here, and they brought the cave in the box to test in testing. And we have the 1218 scripting, which Mustafa and Danlaw will show later today. We do have some learning sessions set up through the week before lunch and after lunch, which should be very beneficial to all of you. And plus, I've also had the opportunity, when I have these test tools, I need devices to test against. So I have a whole array of devices from Denso, Consignia, Harman, Unix, Danlaw, Qualcomm Intrinsic. My wife at home kind of thinks my office is a whole electronics lab and a lot of different stuff. So that's great. The one thing in the V2X Summit that was held here a couple months ago, they sent out a brochure for me to a few of us to review to see if we're missing anything. One of the sections was standards and test procedures, was key lighted in their deployment. I do need to reply back to them. I'd like to see test tools as part of a key item for deployment. Everybody who knows me, I think there needs to be high value test tools for people to be able to deploy. I don't think there's enough emphasis on that for us to be successful to implement. And anything else would you like me to add?
Thanks.
Okay.
Thanks, Randy. That's great. So you can see we have quite a wide range of panelists, from leading test labs and test facilities to test equipment manufacturers to key member of OmniAir to bring all this together. And I'll open it up for some audience questions. I wanted to start off, though, maybe with one kind of leading question for the panelists, just to get things going a little bit. We're talking about connected vehicle testing around the world. And not only to bring insights from each of these different organizations, but look across this panel, and it's insights from all across the world. For the regions that you're involved with, I would love to hear, I think we heard a little bit about where connected vehicle testing is. Love to hear maybe just a little bit more about that, but also where do we need to go to get to an industry-supported certification program in these various regions? And maybe I'll just start in kind of order we did the presentations. Bill, you want to start us off with any thoughts there?
Sure. Should we issue these? Okay, I'll get close to Rosario here. Okay. Yeah, I mean, for me, you might imagine test equipment is kind of center to what we do in 𝗖ście. But I think in the end of the day, in my opinion, it's all about trust. And I covered this last week in 5GA, where I led a work item in 5GA Work Group 3 called CASE. It was Conformity Assessment Strategy Evaluation. And basically, the whole premise of this work item is to come up with or propose a conformity assessment scheme. Now, OmniAir, I'll give lots of credit to, because you guys have a certification program for North America. And I'll give you applause for that, because it doesn't exist in any other region. And so it's a kind of best effort kind of thing. Now, there's a lot of trials going on for sure in China and Europe, but there's not a conformance assessment or certification system anywhere else. And really and that's a shame, because in the end of the day, this stuff has to work, right? It's all about safety, and these things have to interoperate, and they have to do as they're designed. And how do you know that? And Thomas Jaeger presented the mobile phone, right? We all expect our mobile phones just to work anywhere in the world, which is remarkable when you think about it, and interoperate with any base station, any NEM equipment, and any other phone. And how do we get to that level of trust and confidence? Well, these things are certified. They are tested to standards, and everybody has to pass it. For connected vehicles to get to that level of confidence, we need that same infrastructure. At least I think OmniAir thinks so, because you have a program. And we need to get that over to the rest of the world, in particular to the automotive industry. OEMs, the whole ecosystem, we need to get that adopted. And I think that's what we're trying to do. We need to prove that this system is trustworthy, is going to save lives, and in my opinion, the only way to do that is to get this baseline, and a certification program around the world would do that. So
excellent.
That helps.
That's fantastic. Thanks, Bill. Great insight. Rosario, you want to go next? Go ahead. Any thoughts?
No, I think Bill explained
Okay.
very good the question.
Yeah, Rosario, you had some good thoughts, I thought, about the various applications and aspects from around the world that you showed as part of that video, I think, as well, too. Hongjong, I know there's quite a bit going on in Korea. What would it take for Korea to get to a industry-supported certification program?
Yeah, actually, Korean government, as well as some industry organization like ITS Korea, generating such a certification program as well as and standard. And we have some protocol conformance, we have we already with the collaboration with OmniAir, lots of standard is fixed. But in case of the application, there's still open. As I mentioned, there are several applications, and each application has different characteristics. And for example, the one application like EEBL has different requirements for the client and pilot site. So it is, I think it is very hard and important to find the common things in the application. So we need to define the common framework or common part to testing the applications. And if OmniAir and if we can contribute to find common things, we can proceed good opportunity. We can make application testing standard or requirement things.
Great, thanks, Hong-Jong. And maybe I'll wrap up with Randy. Randy, I know you've been involved in North America and now exposure to many areas around the world and testing. What do you think it'd take to get from where we're at to industry-supported certification program?
There's a lot of people that are involved in the standards, and we got to make sure people conform to them. So testing is very valuable, and I think we have a good start in having the device manufacturers participate here, which come from all three regions. We have the test laboratories from the different regions getting involved that can help promote that. And if I missed anybody who I didn't call out of test tools and devices, I do have. It's by mistake. I try to write most of them down, but there's quite a few that I have in that perspective. So no, the one thing I see out there is people's willing to participate in standards. There's people willing to participate in pilots. They need to implement the key items and not do half. I still see too many people not implementing and testing security. It does affect. And I see Jason nodding his back there, but Austin hasn't enabled security in their pilots, as far as I know. So, and we have a lot of, at least in the States, a lot of industry participation. I think they expect OmniAir to do the job. We need everybody's support. I wish we would get more participation from the agency sectors and automotive OEMs and that stuff. Radios are very complex devices. If you implement them properly, they work wonderfully, and you can see how things go. So I certainly hope that we get to the point that we see deployments, and I think certification, conformance, and interoperability is a key segment.
Great, thanks, Randy. Yeah, I thought Randy brought up a good point about this is really where the rubber hits the road. I think the standards. I know as I first started to get involved in standards, it's easy to sit in a standards committee and pontificate about various things. And then you get two different developers develop that standard, and you thought it looked great on paper until you actually saw it, and then you're like, oh, okay, there's a lot of ambiguities there. This is really an opportunity then to refine the technologies, and one of the things I've loved about being involved in the Plugfest over the years is actually this is where the doers do the work. So very good. I have a number of other questions, but I thought I'd save some time for audience questions. We have a wonderful panel from different types of organizations and from all across the world. Any burning questions from the audience that you'd like to pose to the panel? We have an opportunity to pick brains here. Go ahead, Thomas. Oh, Burkinda is going to bring out the microphone. Over here, Burkinda. It's Thomas.
Yeah, maybe I just want to add one thing to actually the very important comments that have been made. I think that building a bridge from Rosario all the way through Bill and the colleague from Korea and also Randy, I think what has been brought up here is quite important to say that the building the bridges is one of the key factors. And as Randy was participating, for example, in the 5G ecosystem, I think that is also an important step on the way to getting things together. I mean, if we are looking for a collaborative system in the future, where this kind of certification environment is maybe building a span all over the world, then actually this kind of things are very important. And Rosario showed, I think, the ecosystem where a lot of organizations are being part of, also the standardization organizations. And in Korea, I think things are getting together. And as we have heard, people are happy to collaborate and to see actually where are the overlapping areas that actually then could bring here the benefits together. So I think that is something fundamentally that we should not forget. I mean, we all love the technology, that is clear on one hand, but on the other hand, I think building these bridges, coming together, creating these ecosystems together, it's super important, especially in these very challenging times that we are all in now. So I think I would like to encourage all of us actually to work on this, and I think that will definitely move us forward. Thank you.
Yeah, great point, Thomas. Any reactions from the panel? Any thoughts on that? Go ahead, Bill.
Yeah, maybe just to add what Thomas said. I mean, as he said, it's a collaborative endeavor. This whole thing, it's global, it's collaborative, and we all really need to work together. And that's where Plugfests or Test Fests, where you want to call them, really come into their own. It's an opportunity for R&D guys to get together and work out the problems, because as we know and we see, there are still problems. There's still some technical issues to overcome, and they will only be overcome by this collaborative effort. So Plugfests are the perfect platform for these things to happen. So I fully agree. It's a collaborative effort here. So
great. Thanks, Bill. Any other thoughts from the panel?
One simple.
Yeah, go ahead, John.
One simple thing, and actually we need to consider how, in perspective of users, actually we need some integrating services for users, because at this time in Korea we are deploying lots of OBUs, RSUs, and people think that why government spend lots of money to infrastructures. I don't know what is that. So just before several years ago, the CITES project hosted by the telecommunication company like AT&T and Sprint. So and then Korea started to starting some CITES V2X services with the smartphone, like a Google Map, like in Korean there's a Korean local services like a Google Map and Waymo. So the application including the V2X information, including spec message. So the turn-by-turn navigation provide a real-time the traffic signal information. So people start to think to that. It is V2X. So in the perspective of standard and test equipment and OBU providers, we need to think. It's time to think about what is the service and how to verifying the services. So at that point, we can make some new opportunities to way of our V2X testing and services.
Great. Thanks, John. Any other questions from the audience? Yeah, go ahead, Jason.
Hey, Jason John Michael, City of Austin, Director of Smart Mobility. So I heard a lot. First of all, I think this is really energetic as far as what we're talking about today. We've talked a little bit about the physical layer. We started the conversation by talking a little bit about the applications and some of the applications that are in testing. One of the things that I find really interesting is that amount of potential energy that we have right now. And there's a lot of interest in the application sets, right? I think that's where we're seeing more interest today than we did this time in 2019. So the question, and it's for each of you, and I think each of you have a unique perspective of this. Randy, from the perspective of what does it take to make application testing successful, to our friends at DECRA and how to get it done, to Thomas and the 𝗪𝗂𝗂𝗏 piece, as well as our friend Dr. Zhong from 𝗪𝗂𝗂𝗀𝗃. So my question is, as we look towards the next era of connected vehicle applications, that's moving at a different pace because of the different players involved than the physical layer. How important is it that we get the physical layer moving towards some level of conformance so that those application providers can provide applications that work across all three regions?
Yeah, great question, Jason. Anyone want to start us off?
Yeah,
Go ahead, Bill.
I'll start. So when you break it down, I mean, to me, the physical layer that we've been testing for years, as you said, I'm hesitant, but to say that it's actually in pretty good shape. It's a lot better than it has been. I remember the very first Plugfest. I mean, things wouldn't work, wouldn't talk to each other. It was head scratching, and we spent a lot of time. But over the years, I would say that the confidence that in the physical layer testing is pretty good. Almost we're past that stage now. And I know looking at our Qualcomms and Autotalks guys, and I really think we're getting out the upper layers now, at least my opinion. And just to touch on the application layer, that's where it all comes together, right? That's where all the physical layer, the protocol, the upper layers, all that comes together at the application layer. So indeed, I think that for me anyway, I could get the other panelists. The physical layer, I think, is in pretty good shape, and we're moving up the stack, so literally, so to speak. So, but that's a great question. Thanks.
Yeah, from my point of view, without the application, the technology has no sense, because we can send RF message to the air, but we have to know what are these messages and to understand this message, and to act in consequence of the message that you are receiving. Then, for me, from my point of view, the application, as you said, we need the base, the lower layer, but without application, we don't have the value of these technologies.
That's great, Rosario. Hong Jong or Randy?
The biggest issue out there right now is the RSUs are very well defined, and from an environmental functionality standpoint, and of course with their implementation in the infrastructure, people are starting to understand how that integrates there, and seems like our infrastructure is fairly far behind in electronics and pushing messages at the proper timing. The RSU is really so much far ahead of what they have out there. So at least in the United States, with the connected intersections and interoperability programs, which one of them actually kicks off this Friday night to their second phase in so-called having interoperability in the infrastructure. However, in the OBU vehicle side, it's a whole different story. We've kind of left that up to the automotive OEMs and their environment to define all that stuff of what it can do and can't do. Got into a discussion with a couple OEMs, and they said all the car has to do is accept VSMs. That's all the minimum requirements it is. And I says, well, how do you market that? And if you're marketing that as a V2V OBU, which does a lot of things, that's nice. But if we want so-called the potential there, whether it's a V2X or a V2I OBU, it must receive the SPATs, the MAPs, the TIMs, and those other messages, because that's what the driver is expecting, is getting that connectivity. If you look at electronics, we started V2X back before the smartphone was invented. And a lot of the things we were concerned about, privacy, anonymity, location accuracy, and that sensor had to do everything well. But radio communications does one thing very well, and that's what we should leverage off. And with the advancements in the automated driver assist vehicles, with the other sensors of radar, LiDAR, helping giving other information in the vehicle, let's let the V2X sensor do its job for communication, non-line of sight type activity. And I think we can really get this deployed. I mean, if we would have started this maybe after the smartphone, we may have been already deployed. The advancements in the GPS, GNS has been amazing, and I still see some people, the testing they've done on, let's say, older devices 5 to 10 years ago, and they think that's still a problem. If they would just use the new technology in the last couple of years, I think they would be very surprised to see where we're at. So we came a long way. Everything is, if you look at your smartphone and your apps, everything is based on time and location. The biggest development that probably the US government ever did back in the 1960s was implement GPS from the space program, because that's what our smartphone's based off. That's what our cars and this V2X is really all about, in protecting lives and safety. So we really need the OBUs, where there are different classes of OBUs, to be defined here, so we can properly take them through the steps through radio, middle layer, and application conformance, and before.
May I just?
Yeah, just one. Yeah, go ahead,
So
Bill.
just one more comment. I think that for LTE V2X is what we're doing today. I think things are pretty stable. But of course, we have NR V2X coming maybe next year, and so I think that's a whole new radio. It's a new radio. It's a new radio schema. So we need to test that. So we're kind of going to have to go back a little bit. And I know 𝗪𝗂, who are here, are talking about a new SDR, which gives us ability to get some test devices to start doing that. So I think the physical, it goes through cycles, right? 2G, 3G, 4G, 5G. So then we got it. So that's going to start again, which is good. That's progress. And then finally, from an OEM standpoint, over-the-air testing, OTA testing is going to be probably a requirement that needs to be looked at, because the vehicle is going to be a node in a connected network. Where previously vehicles were individual entities, now they're part of a network, and the connectivity is going to be important. And that critical radio link between the antennas, wherever they are on vehicles, right, they're hidden everywhere to get the design good, but they need to connect to other vehicles, to infrastructure, to the network. And so so I think from an LTE V2X standpoint, the physical layer is good, but it's waves of new stuff coming. So it's not like it's a treadmill kind of a thing. But I just wanted to add that to your comment. It's a great question, though.
Go ahead, John.
Thank you for your great question. Actually, we need. I can. And as she said, there's a hundred of applications in China, Korea, and US, and we cannot develop hundreds of test cases as the applications. So, and if we define each test requirement for each application, newcomers cannot in the V2X market. So this will be a kind of barriers. So I think we need to define just minimum and common requirement, like SAJ 2945. It defines just minimum performance of the BSM message. I like this standard, and we need a kind of minimum application requirement. For example, minimum requirement for the V2V safety application or a retrofit application or V2I application, just minimum requirement. And with this requirement and test specification, the newcomers come in this area and they can they design their new services. I think that can be a kind of breakthrough point of this area.
Great, thanks, Hong-Jung. Okay, I saw we're at time here, so I think we'll go ahead and wrap this up. I really want to just thank all the panelists, such a great perspective from the various organizations and such experience from many years of doing this work and from all across the world. So please help me one more time in thanking all of our panelists today.
Great job, Mike, and the entire team. Lot to think about there. A lot that goes into testing that we don't think about. But I think what makes all of this unique is that all of our testing, and there's been much testing in the ITS world since the concept of connected vehicles came about, a lot of validation testing, a lot of tests and evaluations for pilots. But we're all really gunning for that certification. And that's sort of the reason that we're so focused on certification is that helps to make the marketplace. And the question of where the marketplace is headed, it will be the subject of our keynote speaker, Dr. Jim Lansford, who has a great global perspective. Dr. Lansford is with Qualcomm, and Qualcomm, if anyone has been truly invested in helping to create the ecosystem for C-V2X. And so really looking forward to his comments after the break about where this marketplace is headed and perhaps how certification can be part of that. So I'm told that we're running a little bit behind schedule. So I'm going to ask what was a 15-minute break that we shrink that down a little bit, so 5 to 10 minutes. Go out there and get some coffee and come on back, and we have a great session between now and lunch. Thank you. Well, for those of you joining us on live stream, I promise you that your monitors were not broken. We had some technical difficulties earlier. We had to project onto the wood paneling because the screen didn't come down. We've figured out that problem, and now you'll be able to see our slides actually in color, not with sort of a warm gold tone. So, and I'm glad that everybody has had plenty of donuts. I hope you're on a sugar rush. You're all excited, because we do have a wonderful series of speakers and panel discussions before lunch. So without further ado, I wanted to introduce our keynote presenter, Dr. Jim Lansford from Qualcomm. Dr. Lansford is familiar to many of you who have been in the wireless communication space for years. He is the director of standards at Qualcomm. He is a member of our board of directors, and within a month he'll be our first board member from Germany, because I understand he is moving to Nuremberg. But he is also a professor at the University of Colorado, where he teaches a number of subjects from cybersecurity to wireless communications. And I was going to read off his resume. Is just outstanding, but he chairs various working groups within Wi-Fi Alliance, IEEE, leadership in OmniAir, of course, active in 5GAA, and in just about every technical standards organization that touches on this technology. You'll find Dr. Lansford, not just here in the United States, but also around the world. And I think, coming from Qualcomm and sort of seeing what's happening in China and the US and elsewhere in the world, he has a really, really important perspective to share about where this market is headed. So without further ado, Dr. Lansford, the floor is yours, sir.
Thank you. Let's see if I can have hola, bom dia if you're from Portugal. Guten Morgen. For those of you, I've got to start working on my German. So anyway, welcome to everyone. Glad to be here. Excited to have the opportunity to chat with you, and maybe I'll even be able to figure this out. We had a little bit of an issue getting these slides, so hopefully they got imported correctly. So let's see. That's so far so good. So as Jason said, I've been around wireless for a long time. I was actually involved in Bluetooth when it first started in 1998. I was with the Wi-Fi Alliance before it was even the Wi-Fi Alliance. It originally started something called the Wireless Ethernet Compatibility Alliance a little over 20 years ago, about 22 years ago. I chaired the automotive task group in the Wi-Fi Alliance. This is automotive applications of Wi-Fi, so infotainment primarily. So we have a recommended practice and market needs and use cases for Wi-Fi in vehicles. I'm the editor of the J3161/1 spec in SAE, which is the vehicle-to-vehicle minimum performance and radio configuration parameters standard. So involved in SAE, Wi-Fi Alliance, don't do Bluetooth much anymore. I chair the Wireless Next Generation Committee in IEEE 802.11, so all the new Wi-Fi standards start in my group. It's kind of the incubator for all new Wi-Fi technologies. Let's see, I'm co-chair of the regulatory in something called the FIRA Consortium, which is ultra-wideband, and that's being used now in automotive for digital key, precision location of as you bring your phone or a fob near a vehicle. Let's see, of course, an OmniAir board. I think that's probably good enough for now. So I'm heavily involved in lots of different wireless things, in different wireless technologies. So I'd like to try to look at the big picture of how all this stuff plays together in the automotive world. And for those of you who are automotive OEMs, I really sympathize with your electromagnetic interference and electromagnetic compatibility issues of trying to integrate about half a dozen different radios into inside a metal cage, a metal and glass cage. That's got to be a challenge to try to make sure that all this stuff doesn't kill each other when you're trying to transmit 6 different technologies at the same time, or receive one while you're transmitting 5 others. So that's some of the challenges we have in trying to deploy wireless technology in vehicular environments. Is we have lots of standards groups that don't always talk to each other, standards that don't always play nice to each other. They tend to can interfere with each other, and so. But what I'm going to talk about today is really the deployment of C-V2X here. This is an exciting technology. It's interesting that this has been around now for over 20 years, right? The initial allocation of spectrum in the United States happened in 1999. so 23 years ago. And we're still working at trying to deploy at scale. We lost some of the spectrum in the United States. Talk a little bit about that, but fundamentally, we have at least 30 megahertz of spectrum in the US. We have more spectrum in some other countries. And so we have the opportunity now, I hope, to finally deploy at scale. We've had a lot of field trials of both DSRC and C-V2X now in the United States. We've had trials in other countries of different technologies. I'll talk a little bit about that. And you heard some of these things already. So first of all, I want to thank all the panelists in Mike's panel. He kind of helped set the stage for this talk really nicely. So I think everybody's probably familiar with the terms, right? V to V, V to I to V. V to P, vehicle to pedestrian. This is an important emerging area, and we're really trying to get our heads wrapped around how to address what are called vulnerable road users, bicyclists, pedestrians, construction workers on the roadside. It's an important use case, an important area to work in to make sure that we can try to protect people who could get killed by a car striking them on the side of the road. And so you can see the bicyclist, and we've had some really nice demos at the last Plugfest we had. We had a demo showing a bicyclist, a vehicle warning the driver that there was a bicycle coming. These are great demonstrations, and now we need to start trying to figure out how to deploy this at scale. And I think, particularly in the United States, we've learned the lesson that having a spectrum allocation doesn't mean you get to keep it. We got to deploy at scale. This is the Federal Communications Commission isn't interested in thousands of devices. They want to see millions of devices. If you want to keep the spectrum, you got to deploy at scale, millions of devices. And that's, I think, one of the good messages here is we have the opportunity now to deploy at scale millions of pedestrians and construction workers and bicyclists, in addition to the vehicles, the 18 or so million new vehicles that are sold in the United States every year, plus all the tens of millions sold in Europe and China. So the idea here is that we have a global opportunity, and there are going to be regional differences, certainly between the US and Europe and China and Korea, and perhaps even some slight differences in other countries. But we have the opportunity now to deploy at scale in a global marketplace. And this is, and there's really two different technologies in play here. And we focus in OmniAir primarily on what we call direct communications, PC5 side link. But there's also a place for vehicle-to-network communication. So you can see in this picture we talk about traffic monitoring centers. That's what TMC means. And so you want to relay information from the vehicle to a traffic monitoring center about incidents that are happening, accidents, ice on the roads, things like that. So you need to be able to transmit information both vehicle to vehicle, low latency, mission critical, safety critical messages between vehicles that can be transmitted in tens of milliseconds. And then you also need to be able to relay messages into the cloud, to traffic monitoring centers through the cellular network, 5G, and someday 6G, but certainly 5G is I think, the focus for now. And so these are all complementary. 4G, 5G networks, where we can look at wide area communications, C-V2X for short-range communications, and in precise positioning. And the way I describe it to people is you really have three bubbles. You have the bubble right around the vehicle where sensors can operate, radar, LiDAR, ultrasonics. Those can work out to tens of meters and maybe even a little longer than that. And they're fundamentally line of sight, right? Radar, LiDAR, they're all mostly line of sight. V2X extends that range and allows you to interact with other vehicles. So sensors like radar are focused on the vehicle itself. When you expand the bubble out to V2X, now you can encompass relaying messages to other vehicles. So V2V communications, you can get messages from infrastructure, I to V, and you can relay messages to the infrastructure, V to I. So that's a little bigger bubble. And then even bigger bubble is the wide area network, the 4G, 5G network. It's harder to keep latencies low in the big bubble, so you wouldn't want to use that for collision avoidance in that last 100 meters. But it's certainly a useful technology for relaying road conditions in traffic monitoring situations. So that's really the way I look at it. And one of the things I think was mentioned in the panel earlier was when V2X was first conceived 20 years ago, we didn't have all these sensors. So the key focus, the main thing that V2X delivers that sensors can't, is non-line of sight and interaction between vehicles, where I can tell another vehicle, hey, I saw a pedestrian in the crosswalk. And so you can advertise that to other vehicles. Or emergency electronic brake light, EBL. You're in fog and you can't see 100 meters ahead of you and somebody slams on their brakes. Again, optical sensors may not be able to see that through the fog, but V2X can relay those messages to you. So these are all complementary technologies. So where are we in terms of global deployments? Well, as you heard in the panel, and again, I want to thank them. They've set this up nicely for you. We have some technology choices to make. In China, they have chosen to go with CV2X. In the U.S., we are on a glide path to go with CV2X. The FCC has indicated that that is the direction that they want to go in their report and order. The rest of the world is a little more mixed. As you heard, that Korea is now doing trials of both DSRC and CV2X technologies, and I'll talk a little bit more about that in a minute. The road infrastructure, again, China seems to be leading the way here, and I'll talk more in detail about what's happening in China. We have some funds that were just allocated in the United States for infrastructure, several $1 billion, and I think this is a great opportunity for us to start deploying infrastructure at scale in the U.S. Again, it's about making sure that we have so many devices on the road that we can preserve the spectrum. Because right now we have Wi-Fi on either side of us in the U.S. In the Uni 4 band and the Uni 5 band, they're right on either side of us. So, in order to keep the spectrum that we have for intelligent transportation, we've got to deploy in large numbers. And then in Korea, we're seeing the working deployment plan, and again, I'll talk more about that in a minute. So, I think a little bit about NCAP. China is moving toward an NCAP. The New Car Assessment Program. This is where you get your stars, how many safety stars you get. So China is definitely moving in that direction over the next couple of years. The U.S. does not currently have a plan to make V2X part of the New Car Assessment Program. And there really aren't any mandates per se. As many of you probably know, about 6 years ago, there was some discussion about having a mandate in the United States, but that didn't go anywhere. So we're looking mostly at offering a carrot, which is an enticement for OEMs to deploy V2X rather than a stick where you have a mandate where you force people to deploy. That seems to be the way that the world is moving. Standards, we certainly, there are many, along with several of you in the room here, we're very much involved in standards, both in SAE, IEEE 1609, and other groups. And then, of course, OmniAir plays a pivotal role here. As I think Bill mentioned, this technology is safety critical, and so you have to have assurance that the devices conform to the standards and that they interoperate. Those are the two key things, right? I'll tell you a quick anecdote if I don't burn up too much time here. I was involved in early days of deployment of ultra-wideband, and we did one of the first interop events we did. One of the vendors showed up with a chipset that couldn't interoperate with anybody else. And it turns out the preamble of the signal, they had flipped the polarity of the signal. And everybody else did it one way, they did it a different way. And we started reading over the spec and realized the spec wasn't absolutely clear which way the polarity of that signal needed to be. They interpreted the spec one way, everybody else interpreted the spec the other way. We go to the first interop event and it's like, wow, this is a problem. These are the kinds of things that interop events like we have in OmniAir are so important for, is implementations. We need to find out where there are issues in the implementations, that the standards are unclear. And the events like we have in these Plugfests let us really see, do the standards, are they perfectly clear on how the implementations are supposed to be done? So really, OmniAir, I think, really plays a super pivotal role in making sure that implementations not only conform to the standards, but they interoperate. And then finally, OEMs. OEMs, obviously, for them, deployment is a major decision. It involves a lot of money, and so they don't like uncertainty. And uncertainty is what we're trying to remove, both in standards and in regulatory so that we can open up a clear path to the OEMs to deploy. Again, the idea is we need millions of vehicles on the road with this technology to preserve the spectrum and to give us the benefits. You know, you saw how many people die every year. Don't know how many of those lives could be saved with this technology, but it's a number bigger than zero. So, no showstoppers. We're making steady progress, but there's been a lot of hard work, and we are hoping, you know, China's going to lead the way. They are the ones that are going to be first to deploy on a mass scale. And so you can see, in fact, we have OEMs in China already committed to deploy, and they will be deploying based on being able to get extra stars and NCAP. So we did actually some demos back even in 2019 in China, and now we have a number of announcements from OEMs that they are committed to deploy, and will be trying to have vehicles on the road to meet the NCAP assessment by next year, really. So again, the NCAP is probably not going to kick in for another couple of years, until probably 2024, but still to try to get out in front of the NCAP. There are companies, OEMs, already integrating products into their cars. I don't read Chinese, and it's kind of an eye chart anyway, but you can see this kind of puts into text what I was just saying, that by 2025, we'll start to see some level of deployment for some percentage of vehicles that will have deployment. By 2030, we would expect to see more than 70% of cars have partial or what they call conditional automated driving. And then by 2035, they expect to see a large chunk of large number of the vehicles that will have fully what they call in the, I guess, fully automated driving. And there's a link here. Hopefully we can distribute the slides if you want to see more. Now, there was a lot of discussion about use cases, and again, I want to. That was a great setup for this, because in China they are really focused on use cases. As Bill said, I think the radio technology we're all pretty comfortable with now. 3GPP defined the Release 14 and 15 standards quite a few years ago now. We understand the radio technology. There's always implementation issues people have to stumble through in the early generation products, but the standards are mature now, and the radios we're seeing here are fairly mature now. So now we need to focus on what do we do with the radios. And so these are three of the use cases that are, I guess you would call day one in China, but there's other use cases as well that I'll talk about in a minute, but these are three of the biggies. And some of these will look familiar to you if you're used to European or American use cases. And that's why it's an interesting opportunity for OmniAir, right, is that OmniAir has been focused largely on the US SAE deployment of the lower layer standards, J3161 family of standards. But in fact, when you get to the applications, those are kind of common across all geographies. The idea of having a forward intersection movement assist or a forward collision warning, these are kind of common applications. So there may be differences in the lower layer. For example, China has a 10 plus 10 megahertz channelization. In the US, we have a single 20. But once you get above the lower layers of the radio, applications now is where the interesting action is. And so you can see these are some of the use cases that they're talking about. These are two V2Vs and an I to V, the red light violation warning. That's having your car rat on you that you are going to run the red light. It's also, I guess, warning other cars that somebody's about to blow through a red light. There have been a lot of trials in China. As I mentioned, they've really taken an aggressive stance to try to move forward to deploy the technology. So it's over 60 cities. And so this kind of map shows the deployments around the different country. I'll go into a little more detail here in a second. But some of these deployments are done by different organizations. So you'll see in a second that these different agencies are sponsoring the different projects and the different deployment trials. And you can see how many different cities and how many different trials there are. MIT has 12 different trial deployments going on, and so on. So throughout the country. So really, they are starting to deploy on expressways, and then they'll be moving beyond expressways into roads that couple into the expressways. And so far, they've already deployed over 20,000 RSUs, which is a number bigger than I think any other country has deployed. Even the United States is only, I think, about 12 to 15,000 RSUs. And they are installing more every day. So, use cases. Here's a good eye chart for you. Look at all these use cases. Some of these are repeated. Some of these are different trials and the different agencies doing their trials. And you heard about some of these earlier in the panel. Like of course, emergency braking is a abnormal vehicle reminder that was mentioned. So you can see that there are a lot of use cases here. And so again, their focus is the radio is fairly mature. Let's focus on the use cases, and let's focus on the applications and how we can make sure that we can enable those. And so you can see that a huge number of use cases here, applications. Some of these are common with some other geographies. Some of these are unique. So this is an example of 4 particular application scenarios. Again, the applications that they're testing in these different cities. And they also have, of course, security that they are interested in as well. So as Randy said, security is kind of, seems like an afterthought for a lot of people, but in fact, it's a pretty important part of the technology. I won't spend a lot of time going through each and every one of these, but you can kind of see that there are a lot of applications that are being evaluated in these trials. So moving on to the U.S., there's actually been some very nice deployments in the U.S., right? And we started out, one of the first ones was actually in Colorado, where I currently live. And that was started out about 4 years ago. But we've had a number of other deployments since then. And we've had a lot of discussion and a lot of analysis of test data by CAMP and some other organizations to try to make sure that we have the ability to perform in congested environments as well as in all kinds of traffic conditions. And you can see that things have kind of accelerated, and we're getting some good OEM involvement. I probably shouldn't go through a list of names because I'll forget somebody, but we have a number of OEMs that are very interested and have taken an active role. For example, at the last Plugfest, we saw an OEM demonstrating the bicycle warning system. So a couple of things that are issues, right? In the United States, as I mentioned, we lost 45 megahertz of the spectrum. So we used to have an ITS band that was 70 megahertz wide plus a 5 megahertz guard band. That lower 45 went away. We're left with 30 megahertz. And the FCC has not announced the final report and order that would allow people to know exactly what's required for type approval. But we do expect, there have been a number of petitions for waivers to be able to ship product. And we do expect the FCC to make some sort of declaration about waiver approvals soon. Don't ask me a date, but we think it'll be sooner rather than later. It won't be a year from now. And once these waivers are announced, I think especially for the roadside units, we'll see some movement towards deployment of the roadside units. And then once the final report and order is issued, we'll see an even faster acceleration among OEMs and others. So we really need some regulatory certainty. I think that was a key theme at a recent workshop, a DOT workshop, is we need regulatory certainty. There's some big money applied here too. So this gives the opportunity for infrastructure to be built out. And OmniAir, of course, is, I think, going to play a pivotal role in making sure that all these roadside units from all these different vendors being deployed by all these different infrastructure owner-operators all play nicely together. And then it's up to us to figure out to make sure that these OEMs that are going to be putting OBUs in their vehicles can play nicely with the roadside infrastructure. Because the money's going to come. We need to make sure we deploy smartly based on the funding we get. This is some of the CVX deployments. And you can see that we've had OEM involvement in almost all of these. And we've had some very good support for this. And again, a lot of these companies are already OmniAir members and are very, very active in helping us make sure that these devices interoperate and conform to the specs. Lastly, I'll talk a little bit about Korea. You heard a little bit about it. I think one of the key messages I want to convey here is that Korea was originally a DSRC country. As you heard, the deployments to date have been DSRC. However, we're looking now at a dual spectrum split where there's some of the spectrum is going to be allocated for LTE V2X, some of the spectrum is going to be allocated for DSRC, while they do basically a technology bake-off. And you can see that the expectation is that by calendar year 2024, that we hope that Korea will select a single technology and expand that over the entire roadside network. That's the hope. So Korea is certainly moving forward, and we hope that these field trials over the next couple of years will really help lay the groundwork for mass deployment in the Korean market. You can see that we have 20 megahertz for LTE V2X, and they have 30 megahertz in DSRC. That's using the 1609.4 multi-channel operation. So they have 3 channels that they would hop around between for using DSRC messages. And again, this spectrum plan would be repurposed, I guess, after they do a technology choice. So Korea is on a path to nationwide deployment, and they have plans in place to deploy at scale. They just need to make a technology choice and move forward aggressively from there. And with that, I think I'm getting close to out of time. I don't know if I have any time for questions, Burkinda. 2 minutes. 2 minutes for questions. I'll take Bill first.
Can you comment on Europe?
Europe, well, you know, we're in Europe. Europe is an interesting, there was a reason why I didn't mention Europe. Europe is complicated, right? And we have this idea that they haven't chosen a technology, so we have this technology neutral approach, and we have 3 channels, and they're going to have technology A and technology B, and then either A or B in the middle, and so things are, well, like I said, it's complicated. And we have some OEMs in Europe that are pretty committed to ITSG5, but we don't know what's going to happen longer term. So Europe is a mixed bag, I guess is what I would say. And perhaps in Europe, we certainly know in Europe there's going to be 4G, 5G wide area network deployments. That's a given. So now the question is, if you assume ITSG5 for some OEMs, what do we do beyond that? And I think that's still an active. In fact, I have colleagues at the ITS meetings this week, in fact, debating those very issues. So, yes.
So I have a question. So just given the engineering cycles, the time for 100% commitment from all of the automotive OEMs to have full deployment, it still takes a little time. But there's some low-hanging fruit out there that we've seen demonstrated for using CV2X to protect vulnerable road users and others. Could you speak to that a little bit? Because I think that really helps to advance some of the goals, at least of the U.S. government, I'm sure governments around the world.
So certainly US DOT has, to the questions about VRUs, vulnerable road users, and US DOT has certainly said that's a high priority for them, is they want to be able to have some sort of strategy to protect vulnerable road users, whether it's bicyclists or construction workers on the side of the highway or whatever. And so there's a lot of active work going on there to try to come up with a robust technique that is something that is cost effective for a bicyclist to put on a bicycle, and will still work nicely with the the OEM OBU deployments. And I think we're really like I said, there's a lot of good work going on, and I think it's again a potential opportunity for OmniAir, because so far our focus has been on RSUs and OBUs. But as the market evolves, we'll see these other kinds of use cases and applications. You know, if a bicycle company wants to get a certified, is there a special class of OBU, or what do we call that thing that goes on the bicycle? Is it an OBU? So there's an interesting opportunity as this market evolves for these other non-vehicular usage. And whether it's bicycles or scooters or pedestrians or whatever, or workers. So I think there's a lot of interesting things, and I've seen this in other technology areas. You start out with a main focus on the primary use case and primary market, and then the market diversifies. It happened in Wi-Fi and in Bluetooth, and so that you start to see things get integrated into other things that people didn't conceive of in the beginning. And you just want to make sure the standards can comprehend that, so that we don't have something that's broken 20 years from now. I think that's, Burkinda's telling me that's all I have time for. All right, thank you, everyone.
Thank you, Dr. Lansford. That was a real whirlwind tour of a lot of exciting things happening around the world. So we have two panels. We're going to get ready for our ready to deploy panel. So we'll hear some validation from some of the industry players, from device manufacturers to carriers to others that are involved in helping to make this ecosystem happen. And so I would like to introduce first Paul Sakamoto. Paul, and I'd ask his panel to come up on stage. So I think we have Laszlo, and we have Leticia, and we have Martin Todev, right, of course, from AutoCrypt. And they're going to have a discussion. So we've had a lot of PowerPoint presentations today. So I think having this back and forth discussion now, I want you to save your hardest questions for this panel. Because I think it'll make for a really interesting discussion. So just very quickly, so Paul Sakamoto is the Senior Director of V2X for Harman International, which of course is a Samsung company. He was the Chief Operating Officer for a number of years for Savari Corporation. He has been involved in the V2X space for longer than perhaps he cares to count. Has also had a storied career in Silicon Valley, starting with Intel. He can tell you about the early days of Silicon Valley at Intel and all of the progress that he's seen across different technologies. And I think having that perspective, not just across multiple technologies, but the global perspective as he travels Europe and Asia. He gave a really great presentation. If you missed it, you can see it on YouTube, but it's from our September monthly membership meeting. I think he's just the perfect person to moderate what I think will be a really exciting panel. So please, for this, welcome.
Well, thank you much for that introduction. You know, after that, I'm sitting there thinking, well, who's going to get up and talk? And then I realized it's me. So, but anyway, thank you for that. Glad to be here again, and I think it's great, after having given a quick presentation at one of the OmniAir meetings recently about which regions are going to deploy first for V2X, to now talk about the more fundamental question, which is, are we actually ready to deploy CV2X or not? And when you really look at that question, I think that our panel today is going to help us get through some thought process on the three big pillars. When you think about the three big pillars of deploying anything on a broad basis, there's a commercial portion, which is, does it make any financial sense at all? Are you going to be able to sell it? Is there some reason that your customers are going to buy and deploy this capability? Because to a certain extent, it's not just a technology, it's a capability, right? It's a capability that could actually be productized. And then the next piece is there government regulation that is actually going to make that, one, allowable, and two, is it going to make it uniform across the region so that this is actually a reasonable commercial project to do? So it props up that other pillar. And then, of course, the other piece is technical. Do we have all the technical pieces checked off? Now, I would say in this room, most of us here, hopefully, believe, yes, we've got it, right, the technical piece. But once again, that is still dependent on those other two, because if you have a change in regulation, if you have a change in the economics of it, all of a sudden, maybe it's not really technically adept anymore, okay? So as a representative here of Harman Corporation, which, as was noted, bought Savari about 18 months ago, I would say CV2X, my starting position is CV2X is ready to deploy. And the reason I'm going to say that is not that everything's completely fixed, but that we actually have processed several orders from our OEM customers where we have actually finished projects that will result in the shipment of several million units over the next few years. Now, several million units, how much is that? Okay, so some of that I can't really publicly disclose, but let's just say it's 10-ish to teen-ish millions of units over a period of several years, which means that it's a single-digit percentage of the annual 80 to 100 million cars that are shipped each year, right? You know, just in very rough terms, that doesn't result in super high saturation. And if you add up all of our competitors and everyone else, we're still probably not doing 10 million units a year of V2X in the 24 and on time frame. I would say, to kind of dovetail to what Jim Lansford said earlier, the first marketplace, as most of you know, is China. It is being, in our opinion, driven by China NCAP. And those OEM customers that are deploying in China that have already done those projects with us, because remember, in automotive, you finish the project several years before it actually ships. So we've put those in the can. They're ready to go. China, of course, has decided that this is important. And I think one of the things we note is, why is it important? Because they have an immediate traffic mitigation problem. You know, I've talked with Chinese officials before who said, in the West, you're concerned about saving lives. We want to save lives too, but actually before we get to that point, we'd like to have the traffic move fast enough that lives could be put in danger more often, right? So it's a different motivation. But in any case, with that, I would say that you know, our position is we're already engaged in shipping this technology. We believe very strongly that C-V2X, at least in the V2V piece, is very much ready to deploy. We're also a shipper, manufacturer, and a shipper of roadside units, or RSUs, and those are also C-V2X primarily, and those are also going out in some quantity through our distribution channels. So we believe in that too, but we also believe that the V2V portion is going to go out first, and we're heavily engaged in that because, of course, we are a tier one. A quick notion about that, you know, 𝗪 was acquired as part of Harman's you know, expansion into connectivity. In fact, I'm part of the connectivity division of Harman. No doubt about it, Harman, which is a Samsung company, is primarily all about great audio equipment, okay? Many, many billions of dollars of great audio equipment. But we do have a substantial multi-billion-dollar presence in automotive, and a lot of that now is connectivity, both in you know, LTE connectivity, and then also in expanding into now V2X. So with that, once again, we're positive, we're gung-ho, we're ready to go, and I've asked the panelists then to consider those three pillars, which is, you know, the technical state. Do we have sufficient performance? Do we have significant silicon support, technical standards, et cetera? Do we have a logistic and readiness level from a commercial level? So if you're going to install RSUs, for instance, do we have the ability to actually install a few 100,000 RSUs in any particular country? And the answer is questionable, right? Questionable. There's all sorts of other questions that come up. The regulatory environment we've already talked about, you know, perhaps who should take the lead. So what I'd like to do is have our panelists at this point introduce themselves, introduce their position on C-V2X readiness, and then after that we'll engage in our lively discussion, okay? So with that, we'll start off with 𝗪cia from Telefonica. 𝗪cia, why don't you go ahead and introduce yourself a little more thoroughly, and also your position on C-V2X readiness.
Okay, thank you. It's a pleasure to be here. I work in innovation department at Telefónica Spain, focus on connected mobility and vehicular communication. Our main focus is to show that 5G is a key player in the mobility of the future, and also to show that the telcos, the telecommunication operators, are a new player in the value chain of the automotive sector. So far, automakers were a world very isolated, as well as telecommunications, and now we have to work together, together with, of course, with tier ones, with tier twos, and many other companies, just to promote this mobility of the future. From 2018, more or less, we have done a lot of proof of concepts regarding cellular V2X, frame E3 ecosystems, a smart city ecosystem, connected vehicles with traffic lights, vehicles with vehicles, etc. Later, we moved to smart roads. For us, the digitalization of roads is very important in order to have roads safer, more efficient, and smarter, of course. Last year, we took this cellular V2X technology and we took to an industrial environment, specifically to a port terminal, just to make the port safer and to connect and to minimize the risk of collision, connecting cranes with with personal, with trucks, etc. This is another part of cellular V2X that can be implemented right now commercially, okay, for industrial environment. Answering to your question, I personally, this is a person, of course, I believe that cellular V2X is not still ready for commercial development. Technically, it's more or less the core functionality of cellular V2X is already ready. Of course, some enhancements are needed, but I think that the two main stoppers for these commercial developments are, first one, I work in Spain, I'm from Europe, so it's urgent to have a definitive commitment in Europe for cellular V2X, as well as it has happened in China or US. And the second stopper for me is to have a global, a certification global model just to test V2B and V2I communications through source rate interface and also through UU interface.
All right, thank you, 𝗪cia. So there we've got one point, I think, just to kind of summarize, 𝗪cia is saying, technically, we probably pretty much have this ready to go. There's a lot of other things that have to fall into place for deployment, though. A deployment's much different than a capability, okay? And with that, let's go ahead and have our opening statement from Martin Todov from AutoCrypt. Martin, AutoCrypt is a provider of security tools for V2X, and go ahead and let him introduce himself and his company and his position.
Thank you very much, Paul. I hope you can hear me. So yeah, my name is Martin. I work for AutoCrypt. We provide V2X cybersecurity. Not only we provide the comprehensive cybersecurity for the automotive industry, and one of our products is related for V2X communications. And as a security provider, it's great to see that there's more, because we don't really care about the network level, because as long as there is some kind of communication, there is need for cybersecurity. And with now with CV2X gaining more and more momentum, that's exciting because we can see more and more deployments on the road. And it's also great because with the involvement of also telecommunication companies, I believe that we can see more collaboration. There's going to be more push for the deployment. And one example that popped into my mind, one example that changed my stance on CV2X was when I had the opportunity to talk to, because originally I'm from Bulgaria, sorry, I'm from Bulgaria, and I had the opportunity to talk to the Ministry of Telecommunication back home, and their stance was very simple. We don't really care about V2X yet because we don't even have Ethernet cables on the highway. And that was very interesting insight because I never considered that, sometimes maybe the Ethernet cables are just not part of the initial road of the building of the road, right? And as Bulgaria is a relatively new member of the European Union, we don't yet have the same infrastructure as Spain, because from what I've been seeing here, the infrastructure looks amazing, and the roads are, the roads looks like they're built with a lot of different cases in mind, and I believe that also V2X could, I presume that there's going to be nice communication, but then also with CV2X, I believe that we can also cover some countries that do not have the same level of infrastructure deployments, and with more flexible communication options is, just having some telecommunication company offer the connectivity. I believe that there's going to be more need for security, and of course, with more deployments, we're going to have more use cases and more applications. So I believe, my stance is that I believe that CV2X is ready. There might be some aspects that need to be ironed out, but I guess with every technology, there's always going to be something that needs to be ironed out in the beginning. Mm-hmm. And even with smartphones, we had some issues in the first generation that we got ironed out eventually. With the more generations it came. Yeah.
Right. So if I can sort of summarize your position, I think you're saying you think CV2X is ready to go. You got to take a first step. The time is now.
Yeah.
Right. Yeah. Okay. Excellent. Thank you. And the next panelist I'd like to introduce is Laszlo Virák from Consignia. One of the interesting things that happened after Savari was acquired by Harman was that companies that used to be our competitors or at best frenemies were now companies that we work with. So 𝗪𝗂𝗂𝗂 is actually a vendor or a partner of Harman, and so it's been great to actually get to know these guys better and to work with their engineering team a lot more. So with that, I'll go ahead and introduce Laszlo, who actually does have one slide that we're going to go ahead and project.
You can skip the slide if you, Anyway, so thank you so much, everyone, for having me here, and thank you so much, Paul. So this is my slide deck, and since we discussed, we should remove all the sales pitches. We removed every single one of them. So this is the first and the last one. And what I really wanted to highlight, and after my intro, I will get to that point. So I'm one of the co-founders and CEO of 𝗪𝗂𝗂𝗂𝗂. But by trade, I'm an engineer, so I really feel comfortable in this room because, I'm surrounded by those who understand the technology and especially the physics behind the magic. And we all know this is not a magic, it's not sci-fi. And that's, I believe, the biggest thing of the readiness of CV2X and V2X in general, that we all know this is, not a sci-fi or a futuristic something. This is actually real, at least for the technology part. But getting back to 𝗪𝗂𝗂𝗂𝗂𝗂, so we are a V2X company. Our dedication is really and focus is really on V2X, but we do almost every aspect of V2X, starting with automotive, smart infrastructure, micromobility, and the whole connected services. So we focus on those areas where we can generate immediate return values, not necessarily financial benefits, but we tend to focus on problems and how to solve the problems with the right technology, which we do believe is V2X technology. But that's the reason we are here. So I don't want to put a huge emphasis on that. And answering those questions, I believe for technology, that's a clear yes. Of course, it's always kind of room for improvement. And I also do believe this is kind of a process. And there is always, improvement ways and upgrading the technology to the next level. But one thing is certain, that we must not wait for a perfect and fully airtight system. Of course, there has to be hard requirements since we are talking about a mission critical and safety critical system, that's for sure. But if we were to wait for eternity, there is your answer. We will never, ever do anything about that. On the logistics side and whether we can deploy the things, I believe that is manageable. And of course, it's pretty hard to say kind of a clear yes, where the whole world is in this, component crisis. But I do believe that's kind of just a small hiccup or a minor roadblock for now. But I do believe the staff, the integrator companies, and all the necessary stakeholders are out there. And we've been doing these deployments, whether we are talking about the automotive or infrastructure, and even for bikes or e-scooters. So that has been started. And we often say that V2X will find its own way. And it's been doing that. Look at the pioneering road operators or cities from the US. And all those who believe that, hey, this technology can provide a nice solution. Maybe there are other technologies out there, but hey, this is kind of the future-proof way to do deployments. So priority services, preemption services, or pedestrian awareness, or other vulnerable road user awareness. Of course, we could do it with infrared or not even with kind of, communication technologies, but that way, we can, have at least something which is there and can serve as a good basis or as a platform. For the commercial part, that's always a tricky question, right? Because you should push down the prices, things like that. But I do believe we will get there, definitely. And for that, we need kind of the mass coming from the auto industry and the whole micromobility industry. And we have to have millions or even tens of millions of cars and other moving objects on our roads. So basically, that's my stand on that.
Okay, so once again, I think I could summarize and say that you also believe C-V2X is ready for deployment, and that we should not let the perfect be the enemy of the good. Okay.
Exactly.
Excellent.
Exactly.
Okay. All right, with that, I think it's clear we got two of us who are thinking we're ready to deploy, one of us who thinks it's technically ready to deploy, but not necessarily ready. And so with that, I think we'll get started on the first question I wanted to ask, which is, when you look at all of this, one of the big things we've already talked about, I think, at this conference and always comes up is the regulatory environment. And I think, how necessary is that to get started? You know, do you think that's the most important thing that we have left to do, or is there something else? So maybe we can start off once again with 𝗪cia. How important is the regulatory environment to getting started?
It's totally necessary because what happens right now is that automakers are very fragmented, and we need this definitive commitment I told before, because automotive connected vehicles, I think that is the main driver just for this connected mobility in the future. And they have to implement cellular V2X. They are the first actors in this story. I believe that once automakers have integrated cellular V2X in a native way in their vehicles, the following steps will come earlier. I think main driver, connected vehicles, and of course they have to be accompanied with the digitalization of roads. Again, I want to highlight the importance not only that of vehicles have to be connected with cellular V2X. It's very important also that roads has to be digitalized. Digitalized with cellular V2X. We can also virtualize some roadside units. We don't have to install roadside units hardware in every point of the road. As a telecommunication operator, besides that, you know that 5G comes with new bands of frequency, bands that are very important, that are harmonized globally, and in many countries we have plans to deploy 5G in in roads. So I think that this is a key point just to accelerate the mobility of the future.
Okay, thank you. Martin, what do you think?
I believe that from standards point of view, I think pretty much the foundation has been set, and we can see that anything that needs some kind of fixing or something that needs to be added, there are already updates going on different sense. Regulatory point of view, there is a little bit more work to do, and from a security perspective point of view, of course, there's also some requirements on how, let's say, security is going to be, how policies regarding the security are going to be handled. But with more deployments on the road, I guess we're going to be able to see also more interest on how security can be regulated. And of course, we need to have more units on the road. We need to have actual users use the technology itself, and this is going to, I believe this is going to also bring the interest of the different regulatory bodies around the world. And that's why I believe in China there's been more regulation, because they have a more secure plan on what's going to happen and how much deployment is going to happen on the road. Mm-hmm. In US, I don't think there is something concrete for now. I believe that there's some ideas, but pretty much the industry's point to just work out everything else, and maybe eventually regulation is going to follow. Europe, I think it's a little bit mixed in my opinion. The European Commission has been active in doing some, especially harmonization, as 𝗪cia mentioned, and which is great, because they're putting the initial first steps, and then the industry can also maybe base it off of this. But then they're not. They're a little bit. How to say? They're very cautious on it because there's no choice. Is it going to be 𝗖𝗔𝗊𝗪 or is it going to be C-V2X? There's not that decision yet, but I believe maybe if the industry moves a little bit faster with more vehicles on the road, more C-V2X enabled cars, we can see that regulatory bodies are also going to move together with it. In my opinion.
Yeah, I think I understand. I sort of feel that way too. If we actually had the weighted numbers happening, a decision would sort of get made de facto, right?
Yeah.
Okay. Laszlo, what do you think?
Well, that was a quite interesting point, what you, Martin, brought up, that, with more vehicles, probably the whole regulation or regulatory environment would be in a better shape. But this is kind of why, V2X is a strange animal, because it's supposed to happen the other way around, right? But getting back to the original point, it's essential to have the right framework, the right regulatory environment, especially we are talking about a communication technology which involves radio and also interoperability. So you have to have these for sure. But again, I mean, that's up to a certain level. And then, of course, you have to have some level of freedom at least to come up with new ideas or better applications, things like that. And obviously, for example, the activity of OmniAir, that's great, and I wish there were more OmniAirs out there, or with a broader scale for other countries or even continents, because that has been really missing from the picture. And even though we've been having these EU Plugfest or plug tests and US plug tests, those are great events to ironing out the standards. But at the end of the day, you have to have a stamp on your product or on your software or the whole system. And that's essential. And that boils down to a fact, which is kind of the trust. So even, since we are communicating with each other in order to be cooperative or collaborative, you have to be 100% sure you understand what the other is speaking to you. I mean, of course, following the standards, that's great. And, putting together the devices and the software pieces, that's also great. But who is kind of the independent party who is putting the stamp on that? And just giving you a short story, we had to develop our own testing softwares, proving ourselves to the customers, but how credible that can be. If you are, the software vendor, the hardware vendor, the system, and you also provide the test tool. And I'm really happy to see that now we have independent parties doing that. And that's why we decided not to sell that stuff to anyone, because if we were to be measured by our own softwares, probably we would be out of business of that part at least. So it's quite crucial. And all those things, the NCAP for China, and also there is an initiative in Europe which really help to the the whole ecosystem to be scaled up a bit at least, or give it a huge boost. And maybe that's supposed to be happening in the United States, but obviously someone has to take the lead on that. Yeah. And maybe that's not, kind of a mandate or a real regulatory environment, but at least having something which is motivating all the players, every single one of us in the ecosystem, that would be
well, it would seem, at least certainly, we don't have an efficient, I think we've got to all agree, we don't have an efficient rollout unless there's a good solid set of standards. Yes. Right. Just as an aside, as a tier one vendor, what Harman would look at it and say is, if you have multiple radios per, a particular type of car around the world, that immediately increases your price somewhere between 5 and 10%. Just bang, right there. Ultimately, you just can't have a bunch of SKUs to do the same thing. You have to try to simplify that, and especially for something that's supposed to be a common communicator, you don't have to go buy a bunch of Ethernet NICs to go on and go plug into different countries. You just have one, right? I think that's another example of how this just needs to happen to make it economical. Okay, thanks. I'll go ahead and shoot off one more question, and then after that we're going to move into audience questions, so you guys hopefully will have some. So I think that the next question I'd like to open up to you all is, so when I started in this, we had DSRC, and then we went from DSRC to C-V2X, and C-V2X is still actually a purpose-built radio, really. It's still PC5 is not something that exists in your cell phone, so therefore it's just for this. What do you think about the impact of, we have the later 3GPP releases are coming out and giving a lot of those capabilities that we need in terms of latency and peer-to-peer and everything to the cellular tools that are out there in 5G and later 6G. What is the impact of that on our PC5 rollout or the C-V2X rollout? Do you think that's going to actually cause everyone to like wait longer until they can get all the way to there? Or do you think that actually we do have an opportunity to strike and get this finally on the road today? That's a tough question. I didn't have that in my notes earlier, but it occurred to me when you guys were talking. So I'll go ahead and start with 𝗪cie, if that's okay with you.
PC5 is we believe from our perspective, we believe that not only PC5 or the new radio side link, also UU communications have to. We are going to have a hybrid model. Not only communications regarding cellular V2X will be through the short range communication. Of course, short communication in 3GPP release, I think that they have done a very good work because they have covered a lot of enhancements. For instance, in release 16, that I think that it's a very important release 16 because we are waiting for this release 16 for being implemented in the chipsets, because release 16, I'm sorry, covers the side link over 5G. You know that this is very important because 5G modulation is going to improve the efficiency. I'm talking about the spectrum, but the spectrum efficiency is going to improve a lot. And in other releases, release 17 or release 18, they have covered ranging, relay, functions, and whatever. But I would like to highlight that UU interface is also very important because when we are talking about a cooperative scenario or collaborative use cases, I think that the intelligence must be on the edge computing. Okay, the intelligence is not only on the vehicles. I think that for these scenarios, when we are talking about cooperative, about collaborative, the intelligence must be distributed. Half of the intelligence will be in the vehicle, and the half of the intelligence will be on the edge computing. I think that is also a change of mind for automakers. Well, I would like to say also that from our perspective, I would like to highlight that 5G, you know, I think that everybody knows here that 5G has great capabilities in terms of bandwidth, ultra-low latencies, and mass connectivity. But this very important. The one capability that comes with 5G standalone, that is network slicing, and I will I'm sorry because it's not your question, I'm aware of it, but I would like to say that 5G is going to be very important because 5G will bring this slice, and we will have a specific slice in the future for vehicular communications. So I think that it's a key, an essential element for the deployment of connected mobility.
Okay, so if I can sort of restate, you're saying it will coexist. Okay, great. Okay, Martin, what do you think?
Well, I hope it doesn't become a burden because we already had a hurdle of switching from one communication technology to another. Mm-hmm. And if we probably move faster with V2V, with V2V communication first, I believe we're going to have more applications on the road, and let's say governments or maybe some operators which are not really sure about the technology itself can also see that the technology is actually saving lives through V2V communications, and then with this one we're going to have also more applications eventually, because in the beginning, of course, we're going to need the V2X's main idea, if my memory is correct, was to save lives by preventing road accidents, and even without communication with the network, maybe with just initial communication just between vehicles, that would be, I think V2X is going to reach its initial goal of just saving lives on the road. And then I hope that the 𝗪C5 and the UU communications are not going to become a hurdle. I believe that just by the industry moving faster with first initially V2V communications would be great for everybody on the road. And then it would open up more doors for more communication, for more applications with the network, with edge computing as well, and for, of course, infrastructure. Cities would probably be more keen on investing for more CV2X or V2X infrastructure so they can improve their traffic. And that would be, we need just the first steps of, let's say, V2V technology first, and then I guess the industry would, or people's interest would grow more and more, and that would help us.
Okay, so you're thinking, get going once again with V2V as fast as we can, use that to roll up the rest of it, and then eventually we'll roll on UU on top of that. Okay, great. Laszlo.
I fully agree with Leticia and Martin, and I just wanted to add to the story that I also fully in support to move as fast as possible. We are also a big believer in 5G technologies and of course other ways of great communications. But here is my question to your question, actually, Paul. I do believe what it really matters whether we can roll it out faster, if it is kind of the next generation 5G on air or any other technology as opposed to CV2X for V2V or V2I. Because, and of course, sorry for oversimplifying this, but putting a bunch of cell towers or small cells in a city, of course, it's almost as similar as putting a bunch of roadside units, whether we are only talking about 𝗪C5 or DSRC, whatnot. Of course, different entities or corporations are pushing that forward, but cost-wise and logistics, things like that can also take time and a lot of efforts. And I do believe it's kind of the mixture of using the existing sensors, next generation 5G or even 6G, and also other communication ways. So what, for example, Jim mentioned, the ultra-wideband based communication. That can be also a great extension for pedestrians or any kind of vulnerable road users, and that is neither DSRC nor V2X, but can be quite handy for us, maybe for the interim period while we get to the real 5G, and I would love to see that, really happening in a dense city, and we can cover all the assisted driving and V2I functionalities and all the safety aspects. But as of today, what we have is 𝗪C5, what is really capable of saving lives, because that's kind of a mission critical requirement. So my message here that we should not wait until we get a better technology, and hopefully that will be a seamless transition from 𝗪C5 to 5G honor, and I know that from the semiconductor companies we have this kind of promise already.
Okay. All right, well, thank you everybody. I think this was a good opening set of questions. I think we have 𝗪𝗂𝗀𝗃 will bring the microphone out, and if there's any questions from the audience, that'd be great. I ask that you make sure that you speak into the microphone that 𝗪𝗂𝗀𝗃 will bring to you, and then we'll try to answer them.
Thank you. Jason Connolly, OmniAir Consortium. So I have a question for each of you. We have a number of government road operators and regulatory representatives of regulatory organizations that are listening on live stream. Others that have been very active in OmniAir. And there's been a big conversation about how do we get this moving forward, especially in the United States. How do we get off center? So from a carrier perspective and a vendor perspective, I would like, if you're looking for one thing that you would ask government regulators, either in the EU or the United States or elsewhere around the world to do to help support deployment, what is that one thing that's needed right now? And maybe start with Laszlo and then move across.
Okay. So certification, I mean, that's my short answer, because that's the most important thing to really guarantee the interoperability and that we have, you know, kind of an ironed out technology. The longer answer is really to focus on those problems which we can solve as of today, and not wait for eternity for again, you know, a completely airtight system, and that each and every single one of the industry segments or markets, there has to be champions and leaders. So for infrastructure like US DOT or the local DOTs, or in the automotive, maybe some regulatory institution. But please, someone really, you know, take the lead on those, because all the vendors and all the contributors and the whole ecosystem, we've been doing this without a real leadership. Unfortunately, I have to say that, because the right guys are still waiting for something. But anyhow, so that would be my kind of second ask, that hey, please, US DOT or other, you know, DOTs, take the lead.
Martin?
As a security provider, I would like to say that I would like to also back what Randy said a little bit earlier, is security shouldn't be an afterthought, and more deployments should include security, and testing also should, I believe, should include security, because as we have the normal internet, we can see that with nice things we're always going to have somebody who wants to ruin the fun for everybody, and we don't want to have this happen on the road, because the idea of V2X is to save lives, and what if somebody comes out of nowhere and just decides to ruin the fun for everybody by by tapping into the communications and creating chaos, pretty much. So I would like to say that to, let's say, road operators or regulatory bodies, say security shouldn't be on the next phase. Like it should be tested, and it should be deployed now together with the technology itself.
Yeah, I agree. It's got to be foundational. If it's not foundational, it's not going to be strong. So, 𝗪cia?
For me, it's a mix. It's a mix of certification. I've said that at the beginning of my speech. I think that global certification must be done with a lot of interoperability tests between brands, models, vehicle infrastructure. It's needed. And also security. Security, we in order to create a trusted V2X ecosystem, not only to ensure the authenticity, just to ensure that you are a player that are trustable and to avoid any type of cyber attack.
Okay. I'm going to weigh in quickly, and I think if I can reframe the question, it would be that what is going to happen? How does government get this going? And the way that government gets V2X going, in my opinion, is, at least in the United States, is through funding management. I don't think it necessarily leads, but I think it incites. You know, government provides the spark. So in some programs, you know, the space program of years ago, government had to lead. In this case, I think what government needs to do is put out that set of regulations, the mandates that we need to have, and additionally, what does that mean? Why does someone in the US do something? Because we're just a bunch of commercial people who do things for grubby money, okay? It's they fund or don't fund the roadways, they allow or don't allow certain tax allowances for corporations and other things, and if they tie that whole very powerful incentive system into V2X, then it's going to happen. It'll just happen. Right? And we see it in our customers already. Why are the car companies engaging in V2X? Because if they have to do another thing that's really expensive, like seat belts, airbags, automatic ABS brakes, things like that, those are super expensive compared to adding a V2X radio, okay? And when you have quiet talks with those OEMs, they'll say, we'd much, much rather cut that off and have a firewall of something like V2X if we can do it, if that will substitute for the next generation safety. And I think, I've said before, the first 100 years of automotive safety were all about crash mediation once you actually have a crash. That is, post-crash safety. The next evolution has got to be not having crashes, right? We've gone about as far as you can armoring up a car. I think that's got to be the next thing. I think everyone here agrees. That's the thing government needs to do, is make that the theme. but they don't necessarily lead it. They just pay us for doing it. It's much different. Okay? All right. Do we have other questions? I think we have time for one or two more, and then I've promised Burkenda we'll land this thing before noon. Okay? It's a question from Sean. I hope I can answer it.
It's one that I don't think we've talked about enough, this Sean Mashew. My question is something that kind of keeps me up at night, which I think all of you probably have an opinion on, which is how do we tie all, I also believe certification is key. And hopefully all the vehicle OEMs will soon realize that the channel and all of these applications in all three markets is only going to be as useful as the weakest link. And so no matter whether everybody's driving, you know, $100,000 luxury cars, they're still going to have a horrible experience if there's any junk devices on that same network sending low quality messages that somehow got certificates, that got enrolled, and were producing maybe BSMs that were not as good as they need to be. So how do we close the gap? And I imagine it's a different answer in China. I kind of suspect they will get that right. Europe, I'm not so sure. But how do we close the gap between our kinds of certification of devices, OBUs, and RSUs? I know there's work underway for RSUs, and actual SCMS enrollment, so that, you know, we don't have to worry about those low-quality devices ruining the channel for everybody and effectively making it an embarrassing problem.
That's a great question.
All of you might have an opinion.
Martin.
Yeah. So I believe it has to be some kind of collaboration between the regulatory bodies and maybe the OEMs themselves, because let's say that we're going to eventually have like a city that's going to be interested in RSU units, and these RSU units are going to have to be going to need their digital certificate. So, of course, with proper security policies, I believe that there is a way to filter out those potentially let's say not useless devices, but we can filter out some of the devices that might bring some more chaos into the system. And yeah, so pretty much it's going to be policy and how devices are going to be controlled before they're enrolled into the system. And by not being enrolled into the SMS system, you're pretty much going to be left out of it because all the other devices are going to ignore your messages, right? They're not certified. They can't be authenticated because there's no digital certificate in them. And by leaving out those those devices, so maybe from a radio point of view, there's going to be a lot of going on. But from the point of view of somebody who's receiving messages, they're going to receive only the messages that are being verified, that are being authenticated by some kind of body. And with proper policy, I believe, especially policy regarding security credential management systems, I believe that we can filter out, initially we can filter out and leave only the necessary devices and or the necessary, let's say, entities on the road that has to communicate with each other and have to broadcast. And we can, that's how we can initially filter out some of the level, in my opinion.
Well, there's that, but I think as a process going on, I know we've participated in a couple of sessions led by ISS, Integrity ISS, to do some bad actor detection and other things, but they were kind of POCs, right? And I think that what you're talking about, Martin, kind of probably needs to be more codified and be something that we do all the time. I mean, this is the 10th Plugfest, right, for OmniAir, but I don't think there's been a 10th, white hat bad actor symposium to go ahead and do that. And I think, there's probably that needs to be thought of. And of course, we're thinking about it late, right? Because I think we've worked so hard on having V2X at all. We haven't thought a lot about that, which is kind of an attack exercise. Yeah. Any other thoughts from anyone?
Yeah, maybe what I would like to add, and I believe this is a great topic, Sean, and not just on the security part, of course, in a much broader scale, misbehavior detection is quite important. but next to the policy, kind of a basic profile, preferably defined by the OEMs or the infrastructure players, that hey, this is the bare minimum in terms of quality of service or reliability of the data I'm sending out. That has to be done. Similarly, what CAMP has been doing and car-to-car communication consortium in Europe. So not just using and defining the standards that, hey, you have to use this 𝗪𝗔 or IEEE or SAE, but how to use it and what should be kind of the minimum performance. And we must avoid the situation what's going on in the car with the CAN buses and FlexRay and MOST and things like that. And even over the OBD2, which was supposed to be kind of the standard, right, for every single one of the vehicles, but unfortunately that's not the case. So it's a challenge, I would say, but with the right misbehavior detection and kind of filtering out or kind of banning those bad actors, there is a promising way, and also defining this minimum quality for the data, which is, I mean, partly is part of the standards. I mean, you have to provide some confidence values to your actual value. So that's, I believe, a good start. But that's just the beginning of the story. It's a bit more complex, but anyway. So I do believe we are on the right track with that, with the OEMs.
Right. I think, Martin, you said you had one more thing?
If I may add one thing also, I completely agree with you. But that if we have more vehicles on the road that are actually communicating with each other, we're going to be able to see, and we're going to be able to evolve more on what is actually misbehaving. Like we do have the basic set of misbehavior, but then with time goes by, there's going to be more, I guess, cases that are going to doubt us, okay, should this be misbehavior? Should this be categorized as misbehavior or not? And now that initially from, let's say, because with certain POCs, we have been able to say, okay, no, this is going to be misbehavior detection, or just from imagining something that's not possible, we can say it's misbehavior. But then with more vehicles on the road, we're going to be able to also produce more ways to to filter out vehicles that are being enrolled but also misbehaving. So we need MBD for sure, but MBD needs to evolve with the more vehicles that are on the road, and it will evolve for sure. Yeah. We just need to have more of going on the road and seeing how are people actually using the technology itself to help and evolve this.
Yeah, no, I agree. We actually had some experience at the POC down in 𝗪𝗂 in Florida, where there weren't any malicious bad actors, but there were definitely, suspicious vehicles, right, that would pop up in the 1,100 cars that were circulating through 𝗪𝗂, and you end up with a certain single-digit percentage that just end up being bad actors because they have a problem. There's a technical problem. They run out of certificates. They're not able to top off again. There's all sorts of things that happen, and then on top of that, at some point we'll have enough cars that there are bad actors, real ones, and it'll be a difficult thing. So I think we're just about to the end of our time. I've got one more question time. One more question? One more question. Right down here. Oh, ready? Bill? Flip a coin.
Let Bill go then. I'm Bill McKinley from 𝗪cie. Sorry, Randy, I'll give it to you just a quick one. Thanks very much, really interesting. I think we're all engineers, and our comfort zone is the technology, but I always push myself, why isn't this taking off faster then? So there's something headwinds, right? And I don't know what it is, and I'm open to your suggestions. We try to engage OEMs, and I don't know how many OEMs are here, but probably not enough, I would say. And so there's a cost thing. I think, I don't know, there's an inherent fear of over-regulation. I take your point with seatbelts and all that, and a radio may be cheaper. I don't know if it's who's going to pay, because I don't know. People just think safety is inherent in any product, and I don't know if people want to pay more for safety. So it has to be built in. So who's going to pay for the rollouts of RSUs or MEC? Who's going to pay for the OEMs to add these things in? I mean, at the end of the day, who's going to pay? The technology, I think we're all comfortable with it. Some issues, but who is going to pay? I'm just curious to how we get this thing kick-started.
I'll take a quick answer. I'll give my quick answer to that, which is two different things. Infrastructure, we don't have a good answer for who's going to pay for the infrastructure yet, which is why we don't have a lot of infrastructure sitting around. the car is pretty clearly the consumer is going to end up paying for this, and it's going to be part of one of those features where, like seatbelts and other things, do you go off and choose a car for the great seatbelts? Some people do. I'd say 99% of people don't. But it's going to be a safety feature like that that's going to be sold at minimal cost, right? And it's going to be done because the car makers felt they had to do it, not because they got to charge more. It's not like a branded audio or something. But that's the way we see it being divided up in practice. Anyone else have any other thoughts? Quick answers? That's okay. If not, we get Randy, and then hopefully I get to stick the landing, and then 𝗪𝗂𝗂 will still like me.
Okay, thank you for our morning session. I just need to announce I did complete the test results spreadsheet for all the test stations. One of the key things we're here is to get these devices ready for certification and walk through all the steps. We want to see testing from all the different sections and where we can implement. I believe the technology is foundationally there. Devices in general from hardware is really ready to be certified. There might be a few software apps that will be added on, but you buy an iPhone or an Android and apps start appearing on it. So let's get this moving forward in that function. I believe they're going to have people who aren't part of the testing to come to see the test stations and test equipment this afternoon. So we have a lot of, we want to get through this week. And of course, my boss will ask me, where's the test results? Where's the test results? And let's get the certification going. So let's see if we can get this done and move it forward. Thank you.
Great, thanks, Randy. Well, I want to thank all of you, audience, and I thank our panelists. Once again, let's give them a big hand. And I guess we'll get back to the hard work of making V2X happen. So thank you very much.
So I know there's, I can hear that little grumble in your bellies. I understand folks are getting hungry. They can smell the lunch that's being prepared outside. It is wonderful, I guarantee you. But before we go to lunch, we have a fireside chat. I guarantee you it won't be boring. We have two Texans who are here to talk to us about what happens in smart cities and how do you have a smart city and smart mobility projects. And when I say two Texans, we have Jason John Michael, who's an OmniAir board member, but also the Director of Smart Mobility for City of Austin. And then we have Mark Sanderson, who's an American, but happens to lead international economic development for the City of Malaga. And if you look around at all of these international companies in this technology park and those that are relocating from cold places like London and to beautiful places like Malaga, a lot of that work is Mark's. But when you do that and you start bringing, and the same thing has happened in the United States, in Austin, a lot of people post-pandemic have decided they want to go to these warmer, sort of nicer cities and relocate, but you have a transportation challenge that you have to meet. You have to think about mobility in a different way, micro-mobility options and transit options and managing that curb space. So there's a lot there, and there's a role for connected mobility in that. So I thought I'd bring these gentlemen down to have what I think will be a fantastic discussion. Jason is known to many of you. I won't give him much more of an introduction, although he is a past chair of OmniAir, serves on our executive committee as our treasurer. So if anyone's asking you for a check later, it's likely to be Jason. But Mark has had a storied career. He was in the very early days of the U.S. Department of Homeland Security, where he was the executive assistant to the Director of Citizenship and Immigration Services. He also served as the Chief of Staff to the United States Ambassador to Spain and Andorra, and then quickly moved to Malaga and has helped make the economic success story that it's become. So I'm going to ask these gentlemen to come onto the stage and have what I think will be a fun conversation. So get your questions ready, and then I promise you we've got a great lunch after this.
Okay. All right, so I'm going to kind of play moderator at the same time. So we're gonna treat this like Mark and I just met, and we're getting to know each other. We're getting to know our cities a little bit more, and we're gonna find that there's gonna be a lot of commonalities probably between our two cities.
We did just meet, though.
That is right. we did. Mark, I found it really interesting the work that you're doing and how you're helping attract some of the unique businesses that are specific in our industry. So it's specific to this area of transportation technology and what it means for our two cities. Can you give a little example of how Malaga got started with its particular journey in this area?
Mm-hmm. Sure, I'd be happy to. First of all, I'd just like to say, thank you to the organizers, to OmniAir, and of course their partners, 𝗪𝗪, and the other companies that are here. On behalf of the mayor of Malaga, Francisco de la Torre, who unfortunately couldn't be here today, we'd hoped that he could have been here to be with you all, but just wanted to welcome you all to the city. Welcome to Malaga. Welcome to the Malaga Tech Park, and hope you have a wonderful conference. I know some of you were here a couple of years ago, so we're excited that you've returned to our wonderful city. But more to your point and to your question, I mean, Malaga, as I think we've talked about, is very similar to Austin in a lot of ways, in the sense that we have to compete with larger cities nearby. In our case, maybe it's Madrid, Barcelona, or Lisbon. But we tried to find a sort of a small niche in technology, and a lot of times in telecommunications. We had the history of very strong telecommunications companies that are present here, which you can see at the park as evident, and obviously 𝗪𝗪 and 𝗪𝗪 Technologies and some of the others that are here. So we really wanted to focus on attracting those companies to our city and offering them something different, a different flavor and different services, perhaps, obviously the quality of life and things like that. So it's been a strategy. The mayor has been the mayor actually for 22 years now, so a lot of it has to do with his leadership and planning. We do have a strategic plan that we followed over the last 20 years, which has really helped guide us and to achieve what we wanted to do, which was to make a cultural city, to celebrate, Pablo Picasso being born here. We've been fortunate that Antonio Banderas has returned to Malaga and is actively, doing things in the theater community. But at the same time, we wanted to balance that out with technology and help the tech park grow. And as you can see, evident from the companies that are present here today, we have over 625 companies here at the tech park and lots of people working here. So that's been our focus, and we've just been grinding away at it, and look a lot to Texas as well and to Austin, given the fact that I'm from there. So have followed you all as well in that sense.
Yeah, and in fact, it's kind of funny. So while you're a fan of Austin, I'm a fan of Malaga. Because one of the things that I find very interesting, something we're trying to do in Austin, is as you see, we're trying to find ways to balance the human to vehicle equation. The United States is definitely a car dominant society, right? Because of how we got started and really how we needed to build out infrastructure in the U.S. In the mid 1900s. But what I find when I come to this town, I typically am taking away things that I want to implement in Austin. So at the same time, I've noticed that from 2019 to now, there's more scooters than there were before, and we talk that just like Austin, about half the people love them, about half the people don't. But what it is it's changing. It's changing how we look at how we operate a city, what a city means culturally. So I think that in Austin, for instance, we too figured out that defining your city culture first and holding on to that, no matter what comes in, no matter what kind of company comes in or what wind comes in that particular decade, that's that huge economic opportunity, those folks are interested in your area or your city because of what you've built around the culture, the people, how happy the people are. Two things that I noticed that are very similar, and when I ask people about either Austin or Malaga, they say, everyone there is so nice. Mm-hmm. And I think that has a lot to do with how we build our cultures and how we connect both our citizenry to our corporate citizens as well. So I'm thinking about, like in Austin, for instance, we've got several different large manufacturers, none the least of which would be Tesla, and now Samsung looking to bring several different battery manufacturing plants to Austin. You know, Elon himself is thinking about building his own private railroad to bring in his own minerals, his own rare earth minerals for his own battery manufacturing plant. So as we look towards how these large initiatives do have an opportunity to make changes, how do you guys look at how you take advantage of that opportunity? How do you build a trusted relationship with those organizations so that they don't misstep along with you, I guess?
Yeah, I think obviously the size of our cities and the size of Malaga is important in that sense. I mean, the population, you know, being really about 570,000 people proper, over 1 million obviously in the metropolitan area, but that allows for kind of more personal touch and close contact with the companies as they arrive. I mean, even to this day, the mayor is still very much involved literally with almost every company that arrives here, certainly the larger companies, in receiving them and welcoming them. You know, this past Friday, we had an office opening for NTT Data, you know, from Japan, and so they, you know, invited the mayor and he went, and so there's still that connection, which is, like you said, it creates trust and a personal relationship that then is easy to work together, and for the city and for those companies and their employees, obviously, to integrate into, like you mentioned earlier as well, which I think Austin has very clearly is a culture, right? And so people, yeah, they want to be a part of that. They want to enjoy the things that are happening. What we do from a city perspective is we obviously try to organize events for the executives and for the employees as they're arriving. You know, we do breakfasts with the mayor. For example, he often likes to hear from those companies, you know, because these are individuals that have lived in other cities around the world. He wants to know what they see is working, what's not working, things like that. But then we also organize events for employees and visits to, you know, tours of the downtown area, cultural tourism and things like that, visits to museums. So we put those activities together for new arrivals, for new employees, again, to help them get integrated into the activities. And of course, send them, you know, newsletters and stuff like that so they can know what's going on. They're oftentimes missing out on some of the jazz festival, you know, that's coming up in a couple of weeks here and things like that, which I know Austin is famous for as well, for music festivals and things like that. But so I think those are the things that are extremely important as the companies and the employees are arriving to your cities.
Yeah, in fact, we just celebrated Austin City Limits the second weekend. It was great. I sent Jason a picture from my little perch underneath an oak tree as we were watching music for the last 3 days. And you know, I find that the cultural piece is one element, right? And you know, what makes a city a smart city? I think cities are always tried to be smart. It's not really a new thing. It's a matter of, can you set yourself on a journey, and can you keep your city on that journey to some degree? Let's switch gears a little bit. You know, with that comes, and with that success comes a whole lot of people moving to Austin, for instance, and where they're moving from is kind of unique too. For Austin, for instance, most of the folks, you know, we keep track of how many people per day are moving into Austin and where they're coming from, where are the majority of them coming from. Prior to the pandemic, most people moving to Austin were coming from California, from the Bay Area, Silicon Valley area, at about 160 people per day prior to the pandemic. We were one of the few cities that grew during the pandemic. We went from 160 to 184 people per day. But New York unseated California during that time. In fact, they still are. Yeah. And so as we look towards the future, you know, some of the challenges that we're facing, some of the things that you and I talked around some of our friends that live and family that live in and around the Central Texas region, is how do we maintain affordability while holding on to the culture and then taking advantage of the business activity and economic development that comes along. But ultimately, it does mean that you're not going to be able to fit everyone into a city. Right. And as we look towards Central Texas, and you think about, you know, from Dallas to San Antonio with Austin in the middle of it, And then I look in this region and I see similar activities. So here we are in this great facility, got planned by regional government and by cities alike, and then we had key companies help come in and be anchor tenants for that, like Tomas and Decker, for instance. And similarly, we're looking at a unique opportunity between two universities in the Austin region as well, both the University of Texas and Texas State University working together to create a new type of technology park specific for mobility as well. When you guys think about how you attract people here and the distance, I guess, between the downtown and the park here, how do you guys handle that kind of conversation with the different businesses that are coming in?
Yeah, I mean, Malaga, similarly, as we said, had grown during the pandemic as well as one of the few cities that saw an increase in population in Spain, while other cities, larger cities, saw decreases. So we know that people are moving here, both companies and employees, but also remote workers, obviously. Malaga has been, in this region, what they call the Costa del Sol, the Sun Coast, has been very popular for more than 50 or 60 years for Europeans when it comes to vacationing. So because of that, we do have a large airport and lots of flights to many places around Europe. And we just recuperated one back to the United States with United Airlines. But we also have a lot of international communities here. So we have international schools and individuals that have lived here now, a lot of times their entire life. So when these people, new citizens are arriving, they can usually find similar countrymen or women in the area, which is helpful. And then again, a school, international school, are available. English, French, we have German, Norwegian, Russian. It's pretty impressive, the list of international schools, which you typically only see in a large capital city, maybe like Madrid. And then also the support from the consular agents. But transportation, obviously the city can only absorb so many people, and people do live along the Costa del Sol, as I mentioned. So transportation is a huge or an important factor that needs to be addressed always. The issue on a local level for Malaga in particular is that unfortunately we don't have a lot of control over certainly the roads within the area. We have to work with the regional government. So access to different places, airport or the technology park and things like that, have to be in close coordination with certainly with the regional government in that sense. But we support, from a city perspective, we've done a lot around the bike lanes and the scooters and things like that. So those have definitely been changes that we've adopted from a city perspective into sort of the new modes of transportation. Obviously, electric vehicles as well. One of the things, we mentioned smart cities before, but Malaga back in 2011 won an award from IBM, the IBM Smarter Cities Challenge, which really sort of set us on a trajectory for doing smart cities projects. And we started, the mayor, really caught that idea and invited companies to come and do pilot projects here in the city. So we did projects with Endesa, the electric company, Telefónica, the telecommunications company, but also with Mitsubishi Motors from Japan. They did a pilot project for electric vehicles from 2012 to 15. So this is, even prior Tesla, we were, building charging stations and had vehicles already circulating the city. So we were already making the changes from, the municipal legal perspective to have parking for electric vehicles and that. So when Tesla and others arrived with their electric vehicles, we were a little bit more prepared, I think, than some other cities, which is fantastic. So the size of the city and the flexibility of the mayor and the openness to invite companies to come and test here has always been something important for Malaga that I think has attracted other companies. I mean, again, obviously the private testing facilities that DECRA has, for example, is fantastic, but there's also always the opportunity to go into the real world and test within the city that we're always opening to do.
Well, that's a great segue into that next little bit, and that's really that conversation that we had around experiential learning, right? Mm-hmm. That there's kind of a good way to maybe finish up this morning too, Jason. Like we've been talking a lot about we're ready, The technology's ready. We're working on the apps. Randy put the charge out there. Let's go, right? What's missing? Well, now you have all the science and technology's done. It's ready or reticent. But anyone that works in a go-to-market strategy knows that you got to get to the customer. You got to define what that is. And for Mark and I, that's our residents and the visitors that come to visit and the businesses that decide to reside and pay taxes in our wonderful cities. And together, when we add all those people together and we create events that give World's Fair kind of approaches, expo types of approaches to how we provide touch and feel experiences for people. The slide I think that Jim may have had up on the screen showcased, or maybe it was Tomas, the number of fatalities that have happened over the last 2 years. We have seen fatalities and serious injuries go up, right? Mostly because of experiential learning. And when you change an environment and don't change the person's training, then they're going to drive aggressively in an open environment, and they're going to drive faster. And what did we see? We saw more crashes. Heck, I think we all kind of, under our breath, said, wow, congestion was a lot safer than we thought, right? That while congestion is bad for a lot of other reasons, from a human safety perspective, congestion is actually safer than open, free speed roads. Now that we're thinking about how do we look at experiential learning moving forward, it gives us an opportunity to then use future events to do more human behavioral shift, to have more change take place. But we can't do it if it was just us as cities, right? It takes our partners in the communities, partners like DECRA and like NTT Data. That it's funny. I'm sure that if we sat down for maybe an hour or so and just tossed different company names back and forth, I wonder how many would end up in the jar of operating both in Austin and Malaga at the same time. But tell me, how do you guys look at how you activate new things when you're in the city? How does the mayor get involved with that when it's not just about the businesses, but more about introducing the businesses and what they're delivering to the public?
Yeah, I think we had the trajectory for smart cities, which was kind of foreign to a lot of the citizens, and it was important for the mayor and his team to communicate that to everyone. As you said, as you adopt new technologies and citizens start to use those, there's obviously a learning curve. So the mayor was very keen on providing different seminars and things like that for citizens and in the different neighborhoods, to bridge the digital gap, if you will. And then the other areas we've kind of been involved in is with working with the Sustainability Development Goals. The mayor was fortunate enough to visit folks in the UN and early on and got on board with the Sustainability Development Goals, and that those have already been integrated into our strategic plan, and so it involves all citizens as well as the companies that are here. And so that's been the way to get more participation and for people to understand that the technology is here to hopefully improve your lives. Obviously, that's what we want it to do. And so I think having that related to the Sustainable Development Goals, knowing that you're working towards a common direction is important, and for the citizens to understand that. So that's been extremely helpful. We have a UN office here that's a training facility, and that they're providing more and more information to the citizens. And then the final way is through our candidacy for Expo 2027. So Malaga is a candidate city with Spain to hopefully host an expo in 2027. But the topic that we've selected is the urban era and sustainability. So it'll touch right on all of these ideas. And of course, what the mayor wants to see is that obviously if we win the bid, which we won't find out until June of next year, but if we win, then we will invite companies and people to come here to have conversations about
how we can build cities that are more sustainable, not only from an environmental perspective, obviously, but from a development perspective as people are arriving, in order to maintain sort of a development in a steady way and not whether it's price gaps and things like that to help everyone. So these are, this is certainly what Malaga is doing, what we want to continue doing, and to be involved in these conversations in our city, but hopefully around the world as well.
Yeah, it's been the level of proactive thinking that goes into it, the creation of these different relationships, not just with other cities. In the case of just you and I think that's what we've noticed in how Austin's helped create sort of a bright spot of conversation around U.S. cities, especially southern U.S. cities, around better understanding our sustainability goals and being able to begin having a conversation publicly, with the community around that. Very similarly, we have South by Southwest. It's kind of a big event if you're familiar with it. We call it the world's largest mega conference these days because of the time and how many attendees. So coming in 2023, we're expecting closer to the old numbers before the pandemic of about 500,000 people for about 10 days straight. As we look towards how we leverage those kind of events to create larger experiential learning sets, definitely welcome you guys to come out and visit that, and maybe we have some wonderful things that we can come and showcase in Malaga and for the expo as well.
Mm-hmm. The South by Southwest, I've seen, I had a chance to attend a couple of times, but I think it's like having an expo kind of like every year. You have an opportunity to bring together leaders and have conversations, but what do you think the impact of that event has been? I mean, it's been going on for decades now, obviously, but how has that impacted the city and the economic development, do you think, for Austin?
Oh, I think to your point, like a lot of cities around the world look at Austin as, all right, how did y'all do that? How did you, under the shadow of Dallas, do all the things that you're doing? How did you attract the world's stack? I call Austin home of the stack. Mm-hmm. There are a lot of other places around the country that, at least in the United States, that build a lot, that press a lot of things, that work on certain parts of it. But if you're interested in really in putting the intelligence on chip in that stack, then a lot of that happens in Austin. Why did it happen? The same reasons. The computing to start with, then telecommunications, Wi-Fi right after that. And then that created a level of cultural competency, I think, in the city that made it easy for them to say yes to South by Southwest, even though it was, some of the inside story, right? Of what does it mean when you permit literally about half of your downtown to one organization to run it for 10 days? Mm-hmm. There's things that happen in the city that aren't their responsibilities that are ours, but it's very interesting in how you manage that image. But what it does do is it gives us that level of cultural competency to continually invest. So regardless of, we're sharing, in November we're going to have a new mayor. We're voting a new mayor in for or half of city council, mm-hmm. And that'll trickle down into city management all the way down to my level. And what's interesting around that is we're also right at the cusp of finishing our strategic direction 2023 that was set out in the early 2000s, and we're setting we're moving towards a more shorter iteration. Now we're just going to do them in 5-year stints, mm-hmm. and so now we're doing a strategic direction 2028. But what South by has done for us is it's built the ability for us to have a continuance of conversation, something that's not just one event that brings everybody together. So we were talking earlier about the stacking of hands geopolitically. Like, it's one thing for you to do it in your city. Can you get the rest of the region to do it, right? And similarly, can I get part of Texas and some of the state of Texas to be with me in that, mm-hmm. right, in that conversation? And that takes a lot more bites at the apple. And that's what South by's been able to do for us, is it's given us the ability to have a long-term conversation that's lasted more than one particular event. Yeah. We have a little bit of time left, I think, right? Just a tiny bit. Are there any questions for Mark and I before I mean, I don't want to stand in between lunch by any means.
Lunch is coming.
I'll just ask a question. I'll be loud, right? So I'm known as loud. So I might need the microphone. So question starting with Mark. So if we're looking around this technology park, there's a lot of companies here from very large vendors for the V2X market, but right down to small startups that we've heard from today. But if they look around, they kind of like what they see, and they say, well, I'd like to be part of this environment. Do you have, what is that sort of next step for them if they're interested, if they're coming from Korea or Taiwan or the United States, and they say, we'd really like to be here because DECRA has great testing facilities, there's a really nice ecosystem. Are you able to sort of accommodate those small startups all the way up to a Panasonic that might look for a footprint here?
Yeah, absolutely. We welcome anyone, any size, and startups, and to the multinationals. But I mean, precisely the facility that we're in today is operated by Pro Malaga, which is a municipal company that operates co-working spaces around the city, including 2 facilities here at the tech park. So, some of the companies that are located here are obviously Spanish companies, but it's also open to international companies as well. But so that's just from the city perspective, and then there's locations throughout the city center and some of the other neighborhoods as well. So, I mean, that would be the first place if you just need office space or a place to go. The next thing, and so there's support definitely from the city perspective, and there's other private incubators as well and co-working spaces. But to get integrated into the community, I mean, we have lots of business clusters already established with the University of Malaga, with the companies here at the tech park. So it's an easy way to get involved depending upon what your sector is and what you're looking for. The tech park itself is actually managed by an entity, and they're responsible for the arrival of the companies and the office space and things like that. And they're the ones that tend to organize the clusters as well. So outside of the park, we also have a digital content lab that's focusing on video game design and virtual reality, augmented reality, and drones and things like that. And so that's another facility outside of the tech park that could be interesting if that's in the sectors that you're looking to, as well as the smart cities. We have again the demonstration facilities and areas where we've done some of the testing, the pilot projects that I've mentioned before, and those are conversations with the city government, with ourselves, that if you're interested in doing pilot projects or working with the city, that we're open to as well. So there's many ways to definitely get involved and to be welcomed here into the city of Malaga.
I'll add that for us, it's so I created the Smart Mobility Office in Austin, which has a connection to our Economic Development Office. And so in Austin, they saw a need to create some specificity around smart mobility systems. More importantly, the mayor wanted to be the kitty hawk of self-driving vehicles. And they set several different council resolutions to accomplish that, and then hired me, tricked me into taking that job. So, a lot of times what I find interesting is my relationship with my economic development friends in the city of Austin. So a lot of times who takes the first intake doesn't really matter. Some of it comes from economic development, some of them come directly to our office. But what happens is we work really cohesively. Usually these companies, at least in Austin, they're just like everybody else moving to Austin. They're looking for a home. It costs a lot more money and usually requires a lot more development to turn that place or that property into what they need. And so because my staff has a lot of the unique nuances around what those companies need, from testing, RF, it doesn't matter, right? Whatever it is, we are a one-stop shop. And so when Ford AV was looking for where they wanted to launch their first self-driving rideshare service in the United States, we were lucky enough to be one of the cities that they were interested in coming and chatting with. after chatting with us, we felt it was pretty solid, and it was. They came right after that because why we provided between us and our economic development office everything that new business, which even though it was an old business, it was a new forward-thinking business, needed. And in fact, they didn't know everything that they needed. And so being able to sit down and us talk through that and have a trusted partnership of, yeah, we can help you figure those things out, and we certainly will make sure to maintain our decorum when it comes to, you know, some of the things that you might not still understand yet about your own business. And that's part of how you build that partnership. So just one of the quick differences, because there's a lot of similarities, but the Smart Mobility office in Austin is now, luckily, GM just announced about 3 weeks ago that they will also be standing up self-driving service in Austin, Texas. So I think we're the first city in the world to, at least in the United States, I'll start there. I think we're the first city in the United States to have two of its country's major OEMs competing in the same marketplace for self-driving rides, which, if you know anything about the industry, there's not a lot of rides to be had. They're very expensive, and none of them are breaking even. So the fact that two major OEMs are willing to compete in the same marketplace, I think it says something about the culture. But again, it comes with that level of service delivery approach to it as well. No more questions? All right.
People are hungry.
I think it's time to eat.
It's time to eat.
Thank you, gentlemen. So I know that if you have questions, I'm sure these gentlemen will be around for a little bit during lunchtime. So if you want to talk about this or their experiences and vehicle connectivity and smart mobility, I'm sure they're happy to share that with you. Thank you. So we are about to go to lunch, and that's a good thing because I understand that Murillo has set up outside just a very fine 5 minutes. I have to fill 5 minutes. Oh my God! So we have a very fine setup for lunch. So we have a couple of minutes. I am going to ask Jeff Kim. Where's Jeff Kim? Is he sitting here? I'm going to ask him to come on up on stage. Come on up, Jeff. So Jeff is with 𝗖cie, and they are leading a new sub-working group within OmniAir on 1609.2.1 test cases. So we heard a lot about security. We really need to test security. Well, this is expanding on the existing security testing that OmniAir is doing. If you are an OmniAir member and you are not part of our working groups, you need to get involved. That's the heart and soul of OmniAir. That's the way that you can contribute to OmniAir. And then you can help us build our certification program, shape it, right? Because we are a bottom-up organization, and if something needs to get done, it's a great opportunity to roll up your sleeves and do it. And for our members in Asia, I know that these calls, especially since Jeff is helping to lead that, are timed perfectly for our members in Asia, and that's not the case for all of our working groups. So this is one to get involved in. Sir, the floor is yours.
Thank you so much, Jason. Yeah, my name is Jeff Kim, and this is Udi. Yeah, we are working at the 𝗪𝗪 Tech. Yes, we are based in South Korea, so we are providing V2X cybersecurity solution to the V2X market. So actually, it's great opportunity and to be a leader of a sub-working group at the cybersecurity working group. So we work with microsec and ISS working closely. So we just started a couple of months ago. So we try to move forward, but I guess it's, you know, not easy easy subject to work. So I like to invite other experts. So we, as you know, the microsec, the 𝗪𝗪 Tech, and the ISS just only expert over cybersecurity. But test cases, we like to invite and discuss and the test equipment company and OBR SU device company as well. So thank you very much.
Tell us a little bit about 𝗪𝗪 Tech.
𝗪𝗪 Tech?
And what you're testing here at Plugfest.
Yes, at 𝗪𝗪 Tech, we're here to, conduct interoperability testing and, ISS and to create something, ISS, SCMS providers, and we also
try to introduce our cybersecurity test technology, test station here. So if you visit our booth here, you can see how it works, and we can show you how it works and the UI, and you can. I would like to get your feedback so we improved our solution with you. Yes, thank you very much.
Thank you.
Yeah.
So, speaking of security, after lunch, come back here. We have a couple of great presentations that are going to be coming in. 𝗪𝗪𝘂𝗀𝘁, the CEO, founder and CEO of Integrity Security Services, and one of the leading members of the SCMS Manager, will be talking about the importance of security testing and the relationship between certification and issuance of security certificates. That's foundational. David's a member of our board of directors, and he'll be offering some featured remarks. Then we have Suzanne Sloan and Jeff Ballone from the U.S. Department of Transportation's 𝗪𝗂𝘂𝗶𝗄𝗄 Center. So if anyone attended the V2X Summit in Washington, D.C. in August, that was Suzanne's organization. She will be, and Jeff will be talking about some of the C-V2X testing they've been conducting over the past couple of years, and some of the test reports that will be going to the FCC, and will be helping to make those decisions about granting waivers. And if anyone is interested about the regulatory certainty, prepare your questions for Suzanne. Also, just know that OmniAir has been very active in that space. We filed comments in support of the waiver requests twice this year. We'll be setting up an ex parte meeting with the Federal Communications Commission in November, going in, making that case that there's a need to grant those waivers now and to deploy now. So with that, I think I've filled up about 5 minutes, and lunch will be served immediately just outdoors. And Burkinda, when do we come back from lunch?
Hello. We'll come back in about an hour.
About an hour. So enjoy. Thank you. Okay, welcome back. No, unfortunately, we've not built a siesta into the schedule, but wasn't that lunch good? So 3 cheers for Murillo for putting together just a really wonderful lunch. Wasn't that great? Well, thank you for sticking around, and I think we do have a very good afternoon scheduled. We have Mr. David 𝗪𝗂𝗂, who is the CEO and co-founder of Integrity Security Services, and he'll talk, and then we have 2 presenters from the U.S. Department of Transportation talking about the results of their V2X testing and where they see things going, what's next in testing. They have some interesting ideas. We've had some conversations with them about what might be integrated into our next Plugfest. And then also this afternoon, we'll be doing some technical tours for some of our guests who may not be involved in testing, but we give them an opportunity to kind of come by and see what's happening and tour the DECRA facilities. And then, of course, this evening, we will board the bus and head to the golf course for a reception. So look forward to that. So hopefully your food digests by then, because we're going to have a fun evening prepared for you guys. So I should have joining us Mr. David 𝗪𝗂𝗂. David, are you online?
I am. Hello. Hi, everyone.
Hey, David. So David 𝗪𝗂𝗂 is an OmniAir board member, a longtime member. Our very first OmniAir workshop focused on cybersecurity in Washington, D.C. David was a part of that, and he's been a part of all the important activities at OmniAir since then. ISS's Jimmy Upton chairs our cybersecurity working group. Of course, Integrity Security Services has provided security certificates in the SCMS for the connected vehicle pilots, and now is spearheading this new SCMS manager group. So when we heard this morning, David, a lot of talk about the need for security in these devices and cybersecurity and driving trust, I thought you would be the perfect person to sort of talk about what's happening in this space and how do we make V2X more secure. So I tell you what, I am going to sit down and then and let you present, and then when it comes time for question and answer, we'll just take some questions from the audience. All right, ready? Sounds good. Thanks, David.
All right, thank you. Next slide, first slide. All right, everyone. I cannot see the slide. Now I can see the slides. Perfect. Well, it's very nice to be with everybody from afar. I'm back here outside of Washington, D.C., and I'm very sad that I couldn't make it to Antonio Banderas's restaurant last night. It sounds like you had a wonderful time. So today, as Jason said, I'll be talking about building trust and security into the connected mobility space, so connected vehicles. My background is I've been in cybersecurity before it was in vogue. I've been doing it for about 18 years. I built provisioning systems for every major semiconductor company in the world, many ECUs, and I'll talk more about that on the next couple slides. Next slide. There's a little, okay, so I'll give a little bit of an infomercial on ISS for those of you that don't know who we are, and then I'll jump right in and talk a little bit about the driving factors that are driving all of this cybersecurity initiatives that seem to be rolling out on a monthly basis. Next slide. All right, so ISS is a wholly owned subsidiary of Green Hills Software. We were founded in 2010. For those of you who don't know Green Hills builds probably the world's most secure operating system. It's called Integrity, hence the name of ISS starts with the word integrity. It ships in over 100 flight critical applications. So anything on an airplane that moves the rudders or does anything with the mission computers, if it's an aerospace and defense aircraft, Integrity runs in that. It also runs in about 20 million vehicles a year. ISS doesn't have is a separate company than Integrity or than Green Hills Software, because we are platform agnostic, meaning our technology runs on any operating system, and and we're end-to-end security experts. And what that means is we go from the device to the back-end infrastructure. So in our world, the example of that would be the onboard unit that's accepting certificates from our back-end system, our SCMS, providing V2X and V2G certificates. My team has got over 250 years of experience. We've secured over 2 billion devices with ISS solutions to date. Next slide, please. As I said, my background is pretty extensive in this space. ISS is made up of two main teams that I knew in the past. One team built the conditional access system for the satellite TV service in North America called DirecTV. The other half of the team built the conditional access system for SiriusXM. For those of you in Europe, that was before we had IP, radio in our cars. So everybody wanted radio without commercials. So SiriusXM built satellites, and it's a pretty successful service. It's in pretty much every vehicle in North America. But we had to build an IP block that went in the chip. Then that chip had to be binded to the radio, and the radio had to be binded to the vehicle. And that was probably 2004 timeframe. And my team and I built the system that ensured that there was no revenue leakage, which means if you paid for the service, you got your value. And back then it was funny, it wasn't really about safety critical, it was more about revenue. So anybody in the encryption space that wanted to make a living had to do something with content protection, because that's pretty much the only place that people played. And since then we've seen an FCA vehicle get recalled by NHTSA to the tune of 1.4 million vehicles. And that wasn't the OEM's fault, right? That was their in-vehicle infotainment system built by Harman that was running an operating system, and they weren't doing code signing on a layer of the software in the in-vehicle infotainment electronic controller unit. And the white hat hackers went through the IVI system and disabled the brakes and steering. So that sort of was a watershed moment for all the OEMs to realize. It was funny because the white hat hackers that did that hack, they probably got into 11 different car brands, if I remember correctly. So there were problems across the auto industry, and it was sort of the perfect event for ISS to be, building our business at the time. So, we captured a lot of that business, but it really starts at the silicon layer. I built systems for every major semiconductor company over the past 18 years for provisioning their chips. So, when you guys are building an OBU or an RSU and you come to us and say, hey, you have to go through a self-attestation to make sure that the chip that you're using in your devices is secure. And, that's sort of the first fundamental tenet of good cybersecurity in IoT devices, because without having a secure place in hardware to secure a private key or a certificate, the whole system, every single layer of software on top of that is not going to be secure. So if you're doing secure boot, if you have an operating system, if you have application, if you have data on top of that, right? Most devices have that similar architecture. In fact, some systems that we work on don't even have an operating system, but we have to find a way to secure them. So that's how we got to that point. Next slide, please. So, building trust in connected safety critical devices. This is a very different concept than, say, building trust in the enterprise. And because you guys are in Europe, right, there's competing standards, right? There's 𝗪𝗂𝘂𝗧 in Europe that's governing the car-to-car industry, and in North America, the V2V industry is governed by IEEE 1609.2. Now, we've been part of this ecosystem since 2014. We built the first SCMS manager for the collision avoidance metrics partnership. We've raised a root in North America. We've raised roots under the 𝗪𝗂𝘂𝘧 standard. We've built SCMS systems to comply with the EU, to comply with North America, to comply with China, to comply with other parts of the world that are adopting one or the other standard. But the main constant is that a car can hurt people, right? And it's about risk management. So from the OEM's perspective, even though you're not building a device that can do harm to someone, if it's communicating with a vehicle, then everything has to be kept to a standard because their business is about managing risk. Sometimes I use the word liability, but I think managing risk is a better word, right? Because they have to ensure, right? If the medicine is worse than the disease, meaning, you know, there's 43,000 deaths in North America due to fatal crashes, right? If we do something to create a connected environment that makes it unsafe, meaning the air interface or the messages aren't correct or the devices can be hacked, then we could be causing a bigger problem than we have today without having this technology. So you have to take a view from the safety critical device. And this is sort of my second point of the talk. It's not just about if you're building a device, right? It's about the vehicle itself. All right, next slide. So I've never, in 18 years of doing cybersecurity and embedded devices, I've never seen so many issues. And they're wide and they're deep. So the supply chain, all the cybersecurity standards and foundations in all IoT devices, not just transportation, and then resiliency. How do you handle it after the fact, right? Many times up until the last couple of years, we would go and we'd talk to people about building a heart defibrillator or building an insulin pump. And they're like, well, there is no attack service. We're not connected. And then all of a sudden, everybody that has an insulin pump or a heart defibrillator wants an app on their phone to monitor what's happening in their body. So all of a sudden, this connected concept to an IoT device becomes critical. And it plays itself out in, obviously, the transportation market, right? Because cars are inherently going to be more and more connected to infrastructure. But in medical devices, in industrial controllers, right? Whether it's your water treatment plants in your country or your oil refineries, everything is becoming connected. The digitization of historically unconnected, embedded real-time devices is critical. And there are more and more hacks in this area that I'll cover later, but you know, there was just a new standard I saw that the EU came out with about cyber resiliency for all electronic devices, right? And there are some that are exempt, but it's everything we've been talking about in ISO 26262 or in the European WP29 standard for transportation, right? We have to ensure that ECUs are locked down in vehicles. And it's not just the OBU anymore, right? More and more cars will have gateways. More and more cars will have ECU to ECU authentication. So it's growing very quickly, and there's just not enough people. This is the third part of the talk. There isn't enough people to address these requirements across the entire industry. You know, even in transportation, much less all of the safety critical industries that we work in. So, you know, I encourage you, if you're a device company and you don't have sort of the cybersecurity capabilities within your company, to reach out to a company that does. Next slide. Next slide. All right, you can, build out this whole slide for me. So here's another way to think about the supply chain. You've got manufacturing, you've got transportation, you've got system integrators, you've got in-system updates, you know, everything that happens has more and more people involved, right? So it's not just I'm a company that's building an OBU or an RSU, right? That company has manufacturing sites. Maybe you have contract manufacturers. Maybe you have consultants that are writing part of the software or doing the hardware design for you, right? And then that goes to a different facility to be built. Then it goes to a different facility to do final tests. Then it gets transported somewhere. And I was in a meeting with an OEM last week, I think it was, and we were talking about trust in the infrastructure, right? Because more and more of the infrastructure operators around the world want the OEM's vehicles to interoperate with all of the roadside units that they're putting up, the traffic controllers. And the OEM is sitting there saying, well, not only does the device have to be secured from design to manufacturing, but how do we know when it's put up that it's operating correctly? We need people to go out into the streets at our intersections and do some sort of validation to ensure the messages are correct coming off of all these devices as well as being secure. So when you think about trust and building trust for mobility and for transportation, you have to consider everything that's going to touch your device and every device your device is going to touch. And then finally, when it's in the field and there's an issue, we want to ensure that the updates are secure, right? Because if you build an update system into a vehicle or into a roadside unit or into an OBU and it's not secure, that's effectively a malware distribution system, right? Because it's very easy to update systems that are built that way. But if they're not secure, anybody could get into the device, create some malware, and update a whole class of devices all at once. And that would be a horrible problem to deal with. Again, that's when the cure is worse than the disease. Next slide. So you can build this whole slide out. This particular slide, I've never seen anything like this. In the last 4 years, the amount of malware in embedded devices is growing exponentially. And this is a testament to how many more IoT devices are being connected to the internet. And that's what I attribute it to, and that's what I believe the truth is. It is probably one of the most scary things I've seen in a long time. And you don't even hear about many of these things. We have a retailer in North America called Target, and they had their HVAC corporate supplier, their network got hacked. They went through the supplier portal at Target and they infected all of the point of sale terminals within Target. And basically the point of sales terminals had malware put on them that what the malware was designed to call home and send people's credit card data from the point of sales terminal, which is supposed to be secure historically, back to their database. This cost Target $200 million or so, and the CEO lost his job over this. But it's pretty frightening when you think about a point of sales terminal that's supposed to be a classically secure device driven by the payment card industry, and something that was connected to it that normally wouldn't be connected to it, someone found their way into a network. So that's sort of a nightmare case where if that was a safety critical application, like a vehicle, like an airplane, like a helicopter, there would be devastating effects. I think there are a couple more build outs here. If you could click the button again. So these are just examples of embedded devices that historically would never be hacked, and they are now seeing more and more malware on them. And I mean, you could just use the Google machine and do searches for these types of things. I encourage everybody to go to NIST's vulnerability database and just type in, a word like Linux or a word like OpenSSL, and you'll see hundreds, if not thousands, of vulnerabilities that have been tracked. So it's a systemic problem, and that sort of leads me to the next slide. So this is a slide from the United States National Security Agency, NSA. And for those of you who aren't familiar, they're part of the DOT. They're sort of this clandestine group, but there's two sides to the NSA. There's the side that plays offense, and there's the side that plays defense. These cybersecurity advisories, right? The defensive side puts them out, but they don't put out a lot of them because the offensive side of the NSA likes vulnerabilities because they like to hack into things. But this one, I think it was back in 2015 or 2016, maybe. This is against Windows, and it's against their certificate authority that runs in the Windows server. And basically what it is signing code for all Windows applications that are running on Windows devices. And what they found is the signing mechanism within the server had vulnerabilities that effectively any signed files or emails or HTTPS connections were vulnerable to attack because of this. This is a certificate authority, which is for the Windows world. So this is analogous to an SCMS for our V2V world. And there are a lot of checks and balances in place that shouldn't allow this to happen. But I have to say, in the enterprise, it happens way too often. And that's why we started SCMS Manager to ensure there's trust across the ecosystem in North America. We are working directly with the EU to ensure that the best ideas from North America are getting to the EU with our electors, with our trustless managers coming this way. But again, if we just simply sort of blindly adopt everything that the enterprise has done in the safety critical transportation market, we will be in a world of hurt. And that is a very, very bad practice. We need to take a lot of their ideas because they've been doing it for a long time, but we need to pare them down to the best ideas for our use cases. Next slide, please. So this is my last slide. This kind of gives a timeline of what we've been doing from 2014, when we built the first SCMS for the GM Cadillac CTS. Then we built an SCMS for the Collision Avoidance Metrics Partnership. And then you can see we've done virtually everything. Back in 2017, we were the first company to do B2B and C2C top-offs over a cellular network with AT&T down to, I think it was a 𝗪𝗂 OBU. And then we signed up several other OEMs. We obviously provided all the certs for the Plugfests for OmniAir. And, today we just keep marching forward. We've got a pretty extensive IP portfolio in this space. We filed quite a few patents on providing secure and scalable SCMSs. And that word scalable is very important. If you're in the market for an SCMS, you need to make sure that your provider scales, because trying to issue certs in North America is a challenge because there's 1,020 per vehicle, right? But in Europe, there's even more. So, you could say that, yeah, we can generate that many certs, but doing it in a FIPS 140-2 level 3 or 4 HSM environment, hardware security module, that's what HSM stands for, is a real challenge. And we've sort of perfected that architecture. Next slide, please. I think I'm going to leave it there. I want to thank Jason and the OmniAir team for inviting me today, and I'll open it up for questions.
Well, great, David. Thank you so much for joining us, and maybe we'll allow David to show his face again and answer some questions. While you're thinking about some of the challenging questions, let me start with this. I was reading last week in the Washington Post about Europol just announced a bust of a theft ring of 31 individuals. And they did this investigation in cooperation with authorities right here in Spain and elsewhere in Europe. And these individuals were using what was purported to be marketed as a diagnostic tool, and they were targeting wireless access, those cars that had key fobs and for remote start, and they were using that diagnostic tool to gain access to that vehicle, take those vehicles and steal them. And that certainly hurts the public trust for wireless technologies, for just access to vehicles. And those stories, as those start to accumulate, what do we need to be aware as we're advocating for the deployment of technologies in cars, safety technologies that don't really have as broad adoption yet? We're hoping for that adoption. Can you maybe talk about the nexus between, security testing and the work that you do, and building that public trust?
Sure. Yeah, and that was an interesting hack. And here's a perfect example of an underpowered CPU, right? Because you can't build a car fob with a secure ECU or a higher end CPU that has the security features that are required. And this is what I'll call fashion over or function over security, right? Everybody wants a wireless fob. Everybody wants to start their car with it, right? The auto industry is a copycat industry. So if one company has it, everybody races to have it too. And now they're moving to something called phone as a key, where your cell phone acts as the key to your vehicle. So you can have an application that you can pick up your Hertz rental car, or you can start your car, or you can have other apps. So it is coming fast and furious. And again, it is the same exact tenets as we have in the SCMS manager and entity attestation report, right? No matter what the device, if it can start a car, that CPU has to be cryptographically protected. And the CPU has to be able to be, hardened to the point where, a common ring of hackers can't get through it. But the challenge is these crime rings, maybe they're not as well funded as a state-sponsored attack, like a China or a Russia or some other country trying to hack into something, but they are very well funded because the assets are enormous, as you saw in this particular hack in Europe.
Thank you. Thank you very much, David. Do we have any questions from the audience? Well, let me ask something. You'd mentioned SCMS Manager, and for those who may not be initiated in that or just not as familiar with that, could you talk a little bit about what the mission of that group is, and then what the nexus is to OmniAir testing and certification? How will that complement or help supplement the testing and certification testing we do and security testing we do on OmniAir?
Absolutely. So the charter of SCMS Manager is to write very specific standards focused on ensuring that there's trust throughout the V2V ecosystem in North America. So to do that, we have a lot of bright minds from the OEMs and consortium partners to create the documents that are on the website. It's open to everyone, and we are going to turn those specs over to test houses through OmniAir, and you guys are going to write, test procedures and implement a certification process depending upon the device. And then we're going to turn those back over to IEEE and 𝗖𝗎𝘂 in Europe and other consortiums around the world to ensure that there's this cross-pollination of best ideas globally. So we've got, interactions from many different countries. We've got interactions from several different SCMSs, providers. We have obviously our OEM partners as part of SCMS Manager. Obviously, OmniAir is a part of SCMS Manager, and we welcome more people.
Excellent. Thank you, David. Okay, questions from the audience. Bill McKinley. Burkinda will be bringing the microphone around momentarily. David, are you able to see the audience? We can see you.
There is a camera shot that showed the whole audience.
Okay.
But I can see your smiling face right now.
What time is it in Virginia right now?
It's 8:12. I'm on to my second cup of coffee.
That's great. You're a champ for doing this. Mr. McKinley.
Yeah, this is Bill McKinley from 𝗪cie. Thanks very much. Really interesting presentation. My company is a test and measurement company, and we're looking at cybersecurity pretty seriously. One of my black belt gurus is in the audience here, my cyber guy. I'm just curious, what do you think is missing? What tools are you missing, or is the cybersecurity industry missing that would really help to try to lock things up quicker, better, faster, cheaper, or whatever? Do you have a kind of hot list, or can we do that offline? I'm just curious.
Yeah, it's a very good question, and you know, part of the challenge for years and years. I mean, we lived in a desert trying to sell cybersecurity to embedded devices for so many years, because people didn't think they had the problem, whether they thought there was an attack surface or not. And the other big problem is that encryption, even though it's the high end of high tech, right? It depends on very complicated polynomials and, you know, advanced number theory when it comes to elliptic curve cryptography. Then you've got sort of the standard that the V2V world was built on, which was, you know, something called butterfly expansion, which was an elliptic curve public key standard. The challenge is there's very few people that understand it, and there's less people that know how to test for it. So, you know, we need to take some of the industry standards that come out of NIST in particular for testing encryption, doing some side channel attacks on CPUs themselves. So my recommendation for a test and measurement company like 𝗪𝗁 would be, you know, just Google side channel attacks, Google power analysis attacks, right? Because there's ways to put an RF antenna on a CPU, and you can, while it's running, you can see this sort of sawtooth on an oscilloscope, and you can actually count out the cryptographic key in some cases if you don't have side channel attack or power analysis protection on your CPU. And once somebody pulls the key out of the chip, then you've effectively, you know, hacked the system. So that's one, you know, quick idea I have for you. But there's, you know, there's others, right? Because it's every element of the device, you know, doing fuzz testing on an OBU or an RSU, hitting it with malformed packets to see if you can break the protocols coming in and out of the box to do black box testing. But, you know, everybody should be doing white box testing. Most of the things to date that OmniAir has been doing is, you know, can your device accept a certificate from an SCMS provider, right? But really, it's and does your radio work properly? But it's, you know, we need to take the next step. We have to do, you know, those power analysis tests. We have to do black box testing. We have to do all sorts of network penetration and fuzz testing with malformed packets on every protocol that goes in and out of these boxes, right? Many of the RSUs have TLS running on it. But if you, like I said, if you go to the NIST National Vulnerability Database and you just type in OpenSSL, you'll see hundreds of vulnerabilities.
Excellent, excellent answer. Any other questions for Mr. 𝗪𝗂𝗧? Well, David, thank you so much for being generous of your time, and I hope you'll entertain any email inquiries that might come out of this.
You bet. Happy to be a part of it, and I'm truly sorry I'm not there with you. It sounds like it's a great event.
We'll look forward to seeing you at the next event. Very good. Thank you.
Bye, guys.
So next up, we have two invited guests from the U.S. Department of Transportation. We have Suzanne Sloan and Jeff Bellone from the U.S. DOT Volpe Center. Are both Suzanne and Jeff able to hear me? Do we have Suzanne online? Okay. So I would just mention that 𝗪𝗂𝘂𝗀𝗃 is a member of the OmniAir Board of Directors. For those of you that are executive members, we have issued a call for nominations for those interested in serving in that capacity. Mike Brown, Jim Lansford, Jason John Michael, all in the audience, all OmniAir board members. If you're interested in that, please do talk to them. Also, the interesting thing about David is that he, one of his team, Mr. Jimmy Upton, also with Integrity Security Services, is chairing our full cybersecurity working group. That working group is working on these types of problems, and it meets on a biweekly cadence, all online. The working group that Jeff Kim talked about a little bit earlier hangs on that. But if you're interested, or if you have team members who have interest and capability and special knowledge of these areas, we'd certainly encourage them to contribute. We want to make sure that OmniAir certified devices are also secure devices. And that goes to building trust in the system, and with certification being a stepping stone on the way to issuance of security certificates and building trust. So lots of opportunities to get involved. I know they're still working here, and I appreciate your patience. I know it is getting to that siesta time, but do not sleep, because we have a great presentation. I'm just going to go ahead while they're connecting and just talk a little bit about OmniAir's working relationship with the US DOT. When I came on board,
recording in progress.
In 2016, OmniAir was in the final stages of a contract with the U.S. Department of Transportation, Federal Highway Administration on next generation V2X certification. And so that was the origin of the DSRC certification program, test cases developed as part of that project. Of course, we've worked with the U.S. DOT over the years, even before my time, as part of the Ann Arbor Safety Pilot, and then, of course, later on cybersecurity issues. And now we continue to work very closely with them. We presented at the V2X Summit this year. We're in constant communication about what we can do to improve our testing to meet some of the needs that the US DOT has identified. Do we have Suzanne Sloan and Jeff Malone? Are you there? Can you hear me? So Suzanne Sloan is the Principal Technical Advisor for the US DOT Volpe Center. Okay. And she helps to lead the Spectrum Policy team at US DOT, and she and Jeff have been working extensively on the V2X testing, or the C-V2X testing that's been happening over the past couple of years, and identifying some really interesting issues that I'm sure that they'll uncover. I understand they're still doing testing. They're doing some final testing even this week. And all of this really helps to go to, one, what OmniAir needs to do to strengthen its certification programs, but two, what needs to happen before the FCC can issue waivers, which is really important in making sure the technology sees rapid deployment. Jeff and Suzanne were instrumental in putting together the V2X Summit that the US DOT held, to outreach to industry over the summertime. And we hope to continue that conversation here today. Suzanne, are you online now? Oh, perfect.
I am. Can you hear me, Jason?
I can hear you just perfectly. Jeff, how are you, sir? Are you there?
I am here too.
What time is it in California, Jeff?
It's what, 5:21?
5:40. You get the award for being the early bird. Well, I will turn the floor over to you, and then once you guys are finished with your presentation, I'll come back up and we'll take the Q&A from the audience.
Okay, thank you.
Yeah, no, that's great. Thank you so much, Jason. Just want to wish everyone a good afternoon. Wish we could be with you in Malaga, Spain. Looks like it's a really nice time to be over there right now. We're so glad to be here virtually as part of your Plugfest. I think, as you all know, a key to any successful connected vehicle environment is the devices, how they perform both individually as well as how they come together as an ad hoc network and actually perform for the various safety and mobility applications and a whole host of other applications that we envision. And then also to understand how they can withstand different types of interference that we know will naturally occur in the environment and may also occur for reasons that we don't want them to occur, such as use of adjacent channels in the spectrum being just a little bit too close, having too much power, emissions leaking into our 30 megahertz. So in 2019, when the SEC mandated interdifferent technology, we went about developing a set of tests that are very similar to the testing that had been done on the previous V2X communication, the DSRC, which had already been in operation. So we had a pretty good understanding of the path that we needed to follow. And then we went about trying to implement that test plan. And of course, as you all know, the pandemic hit at that point, making it a really interesting time for all of us to try to launch testing. But we were successful in getting devices in 2020, working with the different vendors to pull those devices into the right form for doing testing and being able to collect data. And we started our testing in earnest in July of 2021. We finished our field testing in July of 2022, but recognized that there are certain other tests, such as the in-vehicle interference, that we hadn't quite gotten to the place where we needed to be. And so this week, Jeff and a team are doing some of that testing in the laboratory. And we're hoping to complete this in November, where we take a look at it in sort of more realistic type settings as well. So Jeff is about to present a presentation that we presented at the summit. For those of you who were not there, we have a new website that is available. It contains the recording of the summit. And on our website, as Jeff will point out later in the slides, we have a huge amount of data that is accessible. It's a little bit hard to access, but we've provided instructions to walk you through how to access our data in case you're interested in taking a look at it on your own and doing your own analysis. So Jeff will walk you through all these details, and we're happy to take questions afterwards. And certainly if you want to put questions in the chat, we can address them as soon as Jeff is done. So with that, let me turn it over to Jeff Bellone, who's really been our one of our key leads for all of this V2X testing. Jeff?
Okay, great. Thanks, Suzanne. And I guess it's good afternoon, everyone there. It's early morning for me. If we can just move to the first slide. I know we're short on time, so I'll jump right into it. And let's see. Yes, okay. So starting with our test approach, we've had the chance to present on our test plan in the past, and I think most of you here today, are probably pretty familiar with this, so I'll go through this quickly. But it's just important to remind everyone how we really took a comprehensive path to getting to where we are today in terms of understanding the technology. As Suzanne alluded to, we had a broad, the ITS Joint Program Office had a broad agency announcement in 2020. We procured devices from up to 7 different vendors. And we started with just basic lab characterization from the baseline and making sure they all can turn on and off, and that we can set the parameters for our testing. We did some integration testing to make sure everything worked within the system we created for our test plan. And then we did 2 sort of parallel efforts. One, a closed track, controlled track testing at a decommissioned naval air base. And you see the pictures on the slides show, forgive for being sort of small, but they show the setup. And then also some small scale real world testing in Tampa, Florida with one of the connected vehicle pilots. Next slide. So what were we trying to test? We're trying to understand how the LTE-based C-V2X radios perform in a variety of conditions. So you can see sort of, we started with the baseline, as you see in that circle there, but then as you move over to the right, we also wanted to understand how do the devices perform in highly congested areas, and how do they perform in the presence of uni interference, especially under the new FCC rules. and then also just how they perform in a real-world environment. And we adjusted the settings to create baselines so that we could compare performance under each of those conditions to the relative baseline to understand the performance, which I'll talk about in a bit. So if we go to the next slide. So here, this really quickly, this just shows the lab characterization. I think I talked about this, but some of the basic functionality things we tested, the RF characterization, we had receiver sensitivity measurements and transmit power. We noticed some issues that we put there on the right. Several of those issues we were able to work our way through. We just wanted to note some of the things we found, but we were able to work our way through to get the devices in an acceptable form for the testing. So next slide. Okay, so with the controlled track testing, we really broke it into two scenarios, one a line of sight and the other non-line of sight. We performed similar tests under both conditions. We didn't find in our control track, we didn't find as much impact on the non-line of sight as we did when we're in a real-world environment. You have things like buildings and even foliage and whatnot. But we did try to at least create that in the controlled track with using a U-Haul truck. We also had the vehicles moving at higher speeds. So a lot of testing in the past, we focused more on maybe 35 to 40 miles an hour. This testing went up to 80 miles an hour. And the reason we did that is as we understood the standard, the modulation changes based on the speed of the vehicle. So we wanted to see how that would potentially impact performance. You could see the parameter settings were followed to the 𝗣𝗹𝘂𝗴𝗂𝗀𝗋. We tested with congestion mitigation, and we used both onboard units and roadside units. We move to the next slide. Here's a picture of the real-world environment in Tampa. So you can see those yellow lines represent the paths that we took. So we had two vehicles following each other in we didn't close the streets. It was in a real environment. So we kept them as close as possible in that real traffic, trailing each other. And then we would go east to west and north to south, or left to right and up and down in that picture. And then there's a red dot that hopefully you can see there. We had a signal generator placed there to create basically to emulate an outdoor access point to understand how the vehicles would perform in the presence of that interference. And then there's like a light blue dot that represents a roadside unit that was already installed at that intersection where we also received some data. Next slide. So in terms of evaluating the performance, these are the assessment metrics that many of you are probably familiar with, but we looked, again, we're looking at the radio performance. So we want to understand packet error rate, how many packets that were sent were received. We looked at some of the context of that in terms of the gap between successive packets, that's the interpacket gap, how often you had consecutive packets missed. And then also we took readings of the transmit time interval and a channel busy ratio, which I'll talk about more in a minute. Next slide. Okay, so let's start with the impact of uni interference, and we'll go to the next slide. So again, as many of you are very familiar, the FCC published the first report and order. We're still waiting for the second report and order, which will define the rules from this new reallocated band. But in our testing, we took this in consideration. So we had the LTE V2X radios operating on channel 183, so the wider 20 megahertz green channel there. And then when we introduced interference, we had that in the red. So we looked at both what would happen if you had the uni operating right below in the new 45 megahertz and also right above, which would represent a uni 5. And we tested under both of these conditions to understand the impact, which we'll show on the next slide. So here you can see this represents essentially the baseline, but it shows it compared to the uni 4 set at the max out-of-bound emission. So this was on a closed track. You have two charts here. One is showing there's two high-speed vehicles. One is showing the first high-speed vehicle transmitting, the other one showing the second high-speed vehicle transmitting. So the vehicle as a transmitter and as a receiver. And you can see that this is the packet error rate. So in the baseline, you had the vehicles up to, I think we had them about 1,000 or a little over 1,000 meters apart, and they're able to effectively communicate. When we turned on the signal generator at the center between those vehicles, so it was about 500 to 600 meters away from each vehicle when they started, and then the vehicles approached each other and actually crossed each other just about right where that signal generator was located. We saw that with the signal generator set on, I guess it'd be technically channel 177, we had pretty much no impact relative to the baseline in the closed track setting. So if you go to the next slide. However, once we introduce congestion, so to be clear, the one before was just the moving vehicles, so there was only 2 vehicles communicating. Now we're still in the closed track, but now we've added several more radios. So we've added about 250 radios that are all transmitting and receiving within a 300-mile radius. And again, that signal generator is in the center of the center of that array. And now you could see, just based on the lines, I understand the specific numbers are hard to see, but we tried to put a red line along the bottom that shows a 10% packet error rate. And then you can see where the vehicles cross each other with the vertical black line. But you can see when you combine congestion with the interference, you start to see the effective communications range shorten. One vehicle proved more effective at receiving than the other vehicle, or vice versa, which could have something to do with how the antennas are placed. We did characterize antennas and did all that, but there are slight different configurations you can get once you're actually, we don't have the antennas actually installed obviously in the vehicle. So we realized there's some difference there, but you could see the main takeaway from this slide being that the effective range when you add the congestion with the interference is reduced relative to when you just have the interference. Next slide. In the real world, we don't unfortunately have those exact same plots for this slide, but we try to highlight the general takeaways in the bottom. So this is again back in that Tampa drawing we showed earlier. You had the vehicles following each other at an intersection where the signal generator was set up. And what we found was that here, even without congestion, so this is when there was just 2 vehicles, now we noticed that the interference set to that max level impacted the range of communication. So they were still able to communicate within about 350 meters, but you saw the packet error rate go up. And actually, if you go to the next slide, I reminded myself we did have one plot here. Yeah, so you can see along the bottom, essentially when you have the signal generator turned on, you see that the range of effective communications get shortened, and you can also see that in the visuals. So on the far right, when everything is green, that means that the vehicles are able to, they're following each other along that path, they're able to communicate well. But on the far left, as they get further away, you could see from each other, you could see that the red starts to pick up. Next slide. So as Suzanne mentioned, we're actually, and that's why I have my hotel background and trying to make sense at 5 in the morning here. We're doing some additional testing. We did testing already on the impact of in-vehicle interference, but we're trying to gather some more data in a lab setting. So we'll have more on this to come. So stay tuned for that. We'll go to the next slide. Okay, now we'll look at the impact of congestion, which we slightly touched on before. If we go to the next slide. So here back to, I talked about our metrics that we looked at. Channel busy ratio was an important one. We had devices running what's called an ACME.
I apologize. We're having an audio issue. I don't think we're able to hear you. Is the control booth able to get the audio back? Just give us 1 second.
Jeff may be frozen 1 second. I think it's on his end.
Progress.
1 second.
Rise up a little bit. And then when the congestion control algorithm kicks in, it starts to come back down. And I'm just making sure you guys can all see this. Yes, okay. It starts to come back down. Then when you turn off the congestion control algorithm, you start to get to the point that you see in the middle slide, where now the channel is getting near saturation. We call this 1,500 devices. And the reason is when we have 250 actual radios communicating as they're expected to communicate with congestion control turned on, once that congestion control kicks in, they start to send messages instead of every 100 milliseconds, as few as every 600 milliseconds. But what we did is we emulated 1,500 devices by essentially forcing all of those devices to continue to send messages every 100 milliseconds. So essentially 6 times more than you would expect them in this crowded of an environment. And that's where we create the 1,500. The 3,000, that similar approach, but except now I think we had them at every 50 milliseconds. So essentially, it's probably easier to think of it in terms of the number of packets in the air than it is the number of devices. But what we're saying when we say we emulate 1,500 or 3,000 devices is that represents the amount of packets that those many devices would need to transmit. It's the number of packets is really what we're getting at, okay? Now, I know a lot of people, one question we've gotten often is this realistic? Where would we see this type of situation? I think the 3,000 devices is one that for us just more represents, where can we really reach a saturation point on the channel? So that's more of a, I guess at this point, a theoretical extreme for us to understand. However, the 1,500 device, we have received feedback. I know in the Atlanta area, there are areas that, especially, and you can see in the pictures, when you have overpasses on highways, and if you were to have side lanes there, and if you were to have, different types of services all at the same time, that we think it is realistic you could have that amount of packets in that area, and that's why we wanted to understand the performance. So if we can move to the next slide. So here I realize it would have been easier probably to put this up earlier, but this shows the setup at the closed track that I've been trying to verbally explain. Each of those green boxes represents one of the devices that sat on a pod that you can see in the picture. We didn't use actual vehicles. We used these pods where we had mostly OBUs and a few RSUs. And then we had the antennas at average vehicle height. And then we had that open lane in the middle where you had the two vehicles approaching each other from opposite ends. And then, as I mentioned, the red oval there represented where we put the signal generator. So this was how the setup looked for the majority of our data, comes from this closed track setup. You can go to the next slide. So now to the impact of congestion. So that shows you how we reach the congestion. I explained what we mean by the number of devices, but now you can see the difference in performance. So again, this is without any impact, that there was no interference at this point. It was just the devices turned on. And when you had just the two vehicles, they're able to communicate over 1,000 meters apart without any packet loss. When you have the 250, so, when you have all of the actual radios communicating, utilizing their congestion control, the range of effective communication reduces, but it's still, especially within 300 meters, there's minimal packet loss. It's when you get to those higher numbers, so around 1,500, maybe a little less, and I realize we picked these sort of big jumps, but really what we notice is that the impact starts to really happen, I'd say around 1,000 devices. But that's where you start to see the impact in performance. Although you could see even with the 1,500 on one of the vehicles, when you're within 300 meters, you're at least closer to that 10% number than before. But again, it makes sense if you go back to the channel busy ratios, as that channel becomes more saturated with packets, the performance starts to degrade. So if we could go to the next slide. So yeah, so this is where, and I'm trying to make sure we have enough time for questions, and I think we're doing good. So I'm hoping people can get this through the chat, but I'm going to put a link in the chat to our website where you can access all of our data. It's a lot. It's over 11 terabytes of data, and that's because we collected data from every single device all the way. So we had 250 devices. It's every possible pairing. So all of those all the devices that represented congesting devices, we have data on them as well as data on the moving vehicles. If you go to the website and you want to just focus on the moving vehicles, those files are available in CSV format. You can download them on your laptop. You don't need, any special setup. However, if you want to get all of the raw data, since there's so much of it, we put that on a separate Amazon Web Services installation. And I'll say now it's not an ideal way it's working, and we've been working with Amazon to fix this. But when you need to sign in and create an account, and then they will actually ask you to pay for your account. But the data is free and it's available. You just have to ignore that step. And then within a few hours, you will get an email. Some have gotten it quicker than others that will give you access to the data. So the key is if it asks you to pay, do not pay. The data is free. And again, we apologize for that. But all of the raw data is there. There's a data primer that explains how you can map the test cases to the specific data set. And all that is available on the website. We put in the link, and you can get, again, to the Amazon setup as well. If we go to the next slide. So this just explains more about what I just said. It shows maybe a picture here of the Amazon setup. So we have the different folders. So again, when you go in, you can download the data primer first, and that will help you understand how to go through the different folders and find the specific data sets that you might be looking for. And I think on the last slide, I might just have more documentation notes that show, where we got some of our input from previous testing, and also some related testing that's on the last slide. So we can probably just end on that slide there. So we keep up the website, and then we can open up for questions from the floor. Oh, I guess I did have one more. Okay, sorry. I did have one more slide. And I apologize, I'm not controlling the slide, so I couldn't see ahead. So just to note, we showed here the highlights of the impact of interference and the impact of congestion. We have several other test cases that we completed that are available within that data. So we have additional RSU analysis. We did some signal violation warning testing. We did DSRC in the upper 30 megahertz. So all of that data is available in the raw data. But again, we just wanted to focus sort of on the key findings today, but wanted to make sure so we don't miss that. And then yes, I do have a few more slides. So if we just go 2 slides ahead. Because again, I want to make sure we have time for questions. So this is just summarizing what we discussed, and essentially it's the impact of interference. We saw that when in a real world environment, when you had the signal generator set at the max out of bound emission for UNI 4, and again, that's what we I guess set as the max out of bound. The final rules are still being set in the second report and order, but what it used to exist in terms of relative to DSRC in the old setup, we saw that reduces range. But however, in the closed track, we didn't see as great of an impact. Congestion was significantly impacted once we got to those high levels that we showed, right? So over 1,000 devices, or the equivalent of 1,000 devices worth of packets, is when you started to see impact. But overall, I think what we showed is that, and again, we're not testing the application layer, to keep that in mind. We're testing, the lower layers. But overall, the technology was able to allow the vehicles to effectively communicate, especially within that critical 300-meter range, under a variety of conditions. It's when we really got into these extreme conditions where we saw the most impact within that 300 meters. And then the next slide. And then this is an important slide for what you're all in Spain for in terms of certification. Some of the challenges we noticed in the testing and things that we think can be addressed as we mature the technology is one, across the test cases. So this wasn't really specific to a factor. We noticed that the devices would stop transmitting for periods of time. So there would be random skip transmissions where maybe it'd be 1 or 2 seconds would pass without any transmissions. We tested with HARC on. We really didn't expect this to happen. We think this is something we noticed, difference in terms of the different vendors. So we think this is something in the implementation, not a problem in the underlying chipset. But that's something that, again, we wanted to note and pay attention to work together to mature. The congestion control algorithm, we noticed it took a little longer than we originally expected to activate within the moving vehicles. However, some of that might be based on our test setup. It might not actually be a real issue to the congestion control, but it is something we noticed. And then also, while we had 7 vendors, we only had 1 chipset. We're in the process of working with another chipset manufacturer so that we can do some true interoperability testing. Again, key for this audience. So we want to understand interoperability beyond the different implementations, but also under different chipset. And then we also tested with software that was from, I believe, July 2021. So we want to do some additional testing with the newer software, which might address some of the issues we've noted here, such as the skip transmissions, and really see some improvements as well in the GPS and location awareness. But again, as we showed earlier, the moving vehicles, they're able to effectively communicate within 300 meters. We feel comfortable with their ability to do that. But like any emerging technology, there are some things that we wanted to at least note that will be important to work through and potentially create through test procedures with OmniAir, so that we can make sure that whether it's cross-vendor conformance testing, whether it's trying to notice some of the highly congested issues that are hard for an individual vendor perhaps to notice, that we can at least incorporate those into the certification process. And then the next slide. This is what I had jumped to earlier. But yeah, here's the additional resources. So again, these slides are available. I put the link in the chat, and hopefully through OmniAir we can share this around to get these links that informed our testing and some of the related testing. So with that, this time I will close at the end of the slide deck, and we'll open for questioning. I only hear me if someone is talking in the room on that side.
That was
I don't hear anything.
That was about the best 5 a.m. presentation I've ever seen, especially remote all the way to Europe. So Jeff, thank you very much, and thank you, Suzanne, for joining us this morning. I guess let me start with a provocative question. So we had
we all can't hear Jason.
Can you hear me? Testing 1, 2, 3. Tell me when you can hear me, Suzanne.
Oh, we got you now.
Now we can.
Okay, you're going to wish you didn't hear me, because we had a provocative question for one of our panels, right? That there's a hashtag that's going around in the V2X world, ready to deploy. And we turned it into a question mark for one of our panels. Are we ready to deploy? And so I guess the most fundamental question I have is not that the device performance is perfect, not that there aren't problems that have to be addressed, but in your testing, did you see any showstoppers that would prevent, that would raise caution from the FCC issuing initial waivers, or state DOTs beginning some deployment of RSUs, starting down that path, recognizing that there are challenges that have to be addressed? But did you see any complete showstoppers in your testing?
Suzanne, I guess I can take that, Suzanne. No, I think, again, like we noted in the slide, there are still some issues that need to be addressed. but the performance was definitely acceptable from our standpoint, and especially in these critical, we talk a lot about within a 300-meter range where you really need timely information. And we found, based on our results, that the vehicles were able to effectively communicate within that range. So again, yes, we need to work, I think all of us in this community need to work together addressing questions both on the technology landscape and on the policy and on interoperability. But there was no showstoppers that to answer the question directly. And Suzanne, I'll let you add anything you want to add.
Yeah, I think it's really important to note that we are trying to set up some meetings here with the FCC in order to talk about how to get those waivers granted. So we are on the path towards deployment and trying to make this happen.
Excellent. And I wanted to commend Suzanne and the entire USDOT team on their engagement, especially in recent months, with the V2X community and engagement on these issues at the FCC. Incredibly important to make sure we're all working together. OmniAir, likewise, is setting up an ex parte meeting with the FCC in November. We'll be going in and talking about our belief about where we are with waivers. So we appreciate your work in this. And we also appreciate the partnership with the U.S. Department of Transportation and the fact that FHWA Saxton Labs is here with some of their test tools that are open source and contributing to our process. I guess just based on the results, the initial results of the tests, if we're doing our next Plugfest in the spring, and we are, and we're doing this domestic, and we're looking at Florida, so we always pick nice locations. But my question is, what additional testing would you like to see incorporated that might reflect some of these issues that you identified in a Plugfest setting that might be helpful?
Yeah, sure. So I think, again, really basic in some ways, learning more about the cross-vendor performance, I think, is important, and to see as vendors bring devices with updated software. So again, we talked about that we're looking to do that ourselves, but we also want to see as people bring their own product forward, how well that does. And then also, I think what we learned from the testing is, being able to, emulate some level of congestion, I think will help us understand how the devices would perform as we get. So again, this is sort of aiming for an ideal future, right? So it's one thing if we deploy now, there's not a lot, we're waiting to deploy, we're waiting for those waivers. There isn't going to be congestion, but we want to make sure that we're successful going forward as more devices get deployed, that we don't cause issue, and to make sure that we're making efficient use of the spectrum that we have remaining, and ensure that they work. So I think those are a few things that come to my mind.
Excellent. Suzanne?
I think that given the fact that we're going to see much more congested use of spectrum, different uses coming around the connected vehicle, dedicated 30 megahertz, but also other forms of spectrum that we might use, I think we need to start bringing in other forms of devices, so the uni devices, which can actually span quite a range. It's not just the unlicensed Wi-Fi, but there's a number of other types of uses for those unlicensed national information infrastructure type communications. So the ability to bring that in and test in the presence of that kind of operation, just to see what happens if interference comes into the 30 megahertz, I think is going to be important.
Well, that's fantastic. Thank you. Very, very helpful. I open the floor to questions from the audience. And Ms. Cantlow will be bringing the microphone around. So the floor is yours.
Hi, I'm Steve from 𝗪𝗂𝘂𝗧. I have two questions. One is very simple. Could you say which chipset you are using in this test? Could you say?
Yes, we've been using the Qualcomm chipset, which I think is the most ubiquitous as part of the products in the United States.
Okay, I got it. And second question is, in congestion situation, how many packets moving vehicle has received from congestion device? Do you have any data? I want to know how many packets got exactly from congestion situation?
Yes, so that is something that the data that shows in the data. And you can look at it when you see how many packets, I guess you just have to define probably a time window, right? So each test case was roughly, I don't know, 30 seconds, 30 to 60 seconds long. So you could look at the different test cases and you could actually see in the raw data the exact number of packets that were sent over that period of time. But also you could just see in our test plan that we posted that we show how many packets each device is sending. So if the device is sending, a packet every 100 milliseconds, you can calculate out obviously how many packets that would be if there's 250 devices versus if they're sending every 600 milliseconds. So all of that data is available.
Excellent, excellent. Additional questions, burning questions from the audience. This is your one time we have. Yes, sir, Mr. McKinley. Ms. Cantlow? Oh.
Hi, this is Bill McKinley from 𝗖ście. Thanks very much. Great presentation. I think it was our signal generator you were using as the interferer. I'm interested in what power levels that you were using, or did you vary the Wi-Fi power level? But and then the second question, maybe next steps. I'm curious. I guess this was just a raw packet error rate type measurement. It was just raw packets, and we can do calculations on packet losses and so on. But how about next steps? When you get up to the application layer, I'm interested if you've considered, when you add security, what latencies might be involved. Is that something that you're going to get to at a future state? Is it something you've got in the near time frame? Thanks.
Yeah, thanks. Great question. So first, we set the signal generator. We both changed the power and the duty cycle. So we looked at higher loadings. So I think we tested around 60% for one round, and then we did lower levels, so around 10%. And then we set the power at an indoor limit around 13 dBm, as well as I'll say around 30 dBm. Sometimes we would change that a little bit based on the channel that we're sending it on. In terms of the application layer testing, so that obviously is a piece that's missing from this. We're looking at the lower layers. We think that it's important understanding the packet loss and the packet gaps, because that tells you how frequent and how timely the information is. And then assuming that that all works, right, then it's up to the application developers to use that information in their usual proprietary way, right, to send whatever warning that they're going to send. But we haven't done that testing yet. I think that is something we're interested in. We did try to test with different packet sizes. So we did most of the testing with around 200 byte packets. So that would exclude path loss or security credentials. But we also tried to do some test cases with larger packet sizes that would assume, that essentially would emulate if you had security and path loss attached to it. So we did do that testing, but we haven't tested yet with the actual security attached, and that would be something of interest, I think, in the future.
Excellent, thank you.
And I just want to add a great thanks to all of the companies that worked hard on the C-V2X modules for testing, because when we first started our testing, they were still in development, and there were a lot of conversations back and forth about different characters and features that were added in as our testing actually went on. But we used quite a range of different vendors from the test measurement equipment perspective, and so just a great thanks to all of them.
Excellent, thank you. Okay, do we have any additional questions? Well, I hope that you would entertain questions that might come afterwards via email.
Yes, absolutely. And actually on the website, I believe we have it set up where there's a special inbox you can send questions to, especially as you get into the data. And we're monitoring that closely. So that's another way to access us directly on the website with additional questions.
Great. Well, thank you again. Let's have a round of applause. enjoy the rest of your mornings. Thank you.
All right, thank you
Thanks so much. Enjoy the rest of the Plug Fest.
And to bring us to closure, we've had a lot of great speakers today, a lot of panels, a lot of really interesting perspectives. To tie it all together and give a little summation, we've invited Mr. Stephen Novosad, who is the chair of our board of directors. He is an associate vice president with HNTB Corporation. He has been an OmniAir member and an active contributor for a long period of time. And he has helped to lead the Tampa 𝗖𝗂 connected vehicle pilot in the United States. So he has some really interesting perspectives that I asked him to share with us. Mr. Novosad, are you on the phone? Testing 1, 2, 3.
I am now unmuted. Good evening.
Very good, sir. Floor is yours.
Thank you. So good evening, everyone. I just wanted to take a couple of minutes to talk about what's going on there and a couple other things that are happening. First, I'd like to thank all of you for attending the Connected Mobility Workshop. I've understood the workshop has been outstanding. Sorry I couldn't be there, but I hope all of you have gotten a whole lot out of it. I did get to peek at a couple of the sessions, and I thought they were outstanding. I also want to thank 𝗪𝗪 for hosting at their facility. While I've been able to not be there, it is a testament to how good their facilities are as we're hosting our second Plugfest there. So thank you very much, 𝗪𝗪, for that. Also want to thank Jason, Ryan, Randy, Jordan, and especially Kendra for all their hard work they've done making the Plugfest happen. I know doing one in the United States is tough, so it's got to be doubly tough doing one there in Spain. But thank you guys so very much for all you've done. As you know, OmniAir is an international consortium, and as much as we would like to think that the world is in sync with connected vehicle technology, unfortunately, that's not the case. Part of the world is very progressive and moving forward at a very rapid pace, while others are still trying to establish their ground truth. Everyone probably knows what I'm talking about. But we feel like OmniAir is well positioned to support all aspects of where the world, in the world where device certification is needed. This is evidenced by the participation of our members in this Plugfest. And I'd just like to take now, I guess, a couple of minutes, and as Jason was talking about the 𝗖𝗂 pilot, and just kind of give you a wrap up of that. The 𝗖𝗂 Tampa Hillsborough Expressway Authority connected vehicle pilot in Tampa started in 2015 and September 2015, and wrapped up in September of 2022, so just last month. 7 years of a very successful pilot. The pilot was initially 3 phases, but after the success of the first 3 phases, 𝗖𝗂 and USDOT came to an agreement to enter into a 4th phase, which I really feel like was a very valuable phase for connected vehicle technology. And the reason behind that is we were able to bring on board Hyundai, Honda, and Toyota as partners. And we actually recruited their customers to be part of the pilot. They had the 𝗖𝗂 apps developed as that were part of the pilot. And they also implemented red light violation warning. They put them on their customers' vehicles. We actually had a dealership participate, which I consider to be a huge step forward. So there's a Honda dealership in Brandon, Florida, that now has technicians capable of installing and making operational aftermarket devices in vehicles. We received lots of very good feedback on that. Some of the numbers that we saw were, over the life of the pilot, we prevented 17 wrong ways. We had over 20 pedestrian collision warnings that kept people from hitting pedestrians. We had thousands of speed advisories posted. And so we just did a survey recently, and the feedback on it was the most valuable piece people felt like was the safety aspect of, they felt comfortable, they felt more safer. And so just a really, really good overall feeling for the pilot. And 𝗖𝗂 is now moving forward beyond the pilot. They continue to operate the system, and they will be building on it in the future. As soon as right now we're still operating in DSRC, channel 180, as that's allowed by the FCC. But as soon as CV2X is approved or the waivers are granted, we'll be transitioning to CV2X. And 𝗖𝗄 has already positioned their infrastructure roadside units as well as their onboard units to be able to, with the configuration change, be able to make that happen. We've already tested it, we've proven it works, and we're ready to go. I just want to shift back to the Plugfest now for just a few more seconds, if you don't mind. I know there's a couple more days of testing going on there. Where hopefully everyone's having success with their testing. I know that from feedback that I get from all aspects of the test tools, the test software, and of course the device manufacturers, that it's very, very valuable for them to have this time to understand how to test their devices and move toward OmniAir certification. I hope everyone finds their time productive and inspiring. So I'm not going to keep people very long, so I just want to close by saying, kind of do my little soapbox spiel that I've done many times. But in closing, I want to encourage everyone to collaborate and come together to influence how we save lives of our families. And my soapbox spiel is I'm especially focused on my 5 grandchildren, the oldest of which will be driving in 3 years. So I really would like him to have the technology in the car as he learns to drive. So together, let's make a statement and let's make deployments happen. So thank you for your time. I appreciate it very much. I appreciate all the people there. And I hope everyone has success, enjoys the beautiful Spain country and Malaga. And I wish you the best. Jason?
Thank you, Mr. Chairman. That was pitch perfect. A great way to finish. Do we have any questions for Mr. Novosad? I'm being told we don't have time. Thank you, sir, again, and enjoy the rest of your morning.
Thank you all.
So I wanted to thank each of you for your patience and joining us, but I think we had some really good discussions. We have even better testing that's happening this week. We're headed over shortly. Are we walking? Is everyone walking over?
So we have buses for everybody.
Okay, and the buses are going to DECRA now, and then the buses for the tours, and then the buses will go. When does everyone board for the reception?
I believe it's 5 o'clock. So you guys will board at 5 o'clock for the reception right now if you guys want to head right out there. We do have a special appearance from the mayor. He does want to see everybody, meet everybody, so he'll be there pretty much in a few minutes.
Okay, well, so before we do, I want to end on the note that I started on. Nothing great is ever accomplished by an individual alone, but it's by teamwork. And this week we've had an outstanding team. So first up, I want to invite Murillo to come up and just say hello to everybody. Come on up. We're going to get you on camera. So Murillo organized soup to nuts, the Plugfest. We don't have hands and feet on the ground here, but Murillo has been excellent, just a wonderful partner. Working, of course, with Tomas and with Rosario. Let's big hand of applause for Murillo and for the team. Now, the swank-dressed individual over there in the Italian, not you, Mr. Ryan Hall. So, helping to put together a Plugfest takes financial resources. As many of you know, if you haven't paid your Plugfest bill, you'll get a call from Ryan very shortly. But he has been the architect of our Plugfest since the beginning, and everything from Saturday afternoon, much of the day, putting together the testing schedule and then putting together again and again, to helping with slides, everything. Mr. Hall's just been outstanding. Let's hear it for Mr. Hall. Ms. Cantlow, come on up, Ms. Cantlow. So, newest member of the team, she had baptism by fire at our Ohio Plugfest. She was exposed to it, said, what did I join? What kind of organization is this? And then this year I said to Brenda Cantlow, I said, we're going to try something different for the workshop. We're going to try to not only bring in people from the U.S. in a strange place where we don't know if the AV works or the Wi-Fi works. We're going to bring them in and have them present. And to make it more complicated, we're also going to live stream it to everybody. And she said, what? And I said, I'm sure you'll figure it out. And by goodness, she did. Put together this, was up late last night, putting everything together, making sure that it was flawless, and it was. and has been incredibly helpful in putting together the week. And if you get a call from her, it's not for money, it's just to help making your membership experience better. So let's give it up to Ms. Cantlow. And thank you again to Dekra and to Tomas, and to thank you to the AV team who helped us out today, and to the Technology Park, and of course the City of Malaga. And we look forward to seeing the mayor. So when the mayor comes by, be on your best behavior. We'll make sure we get some photographs. And if you have a chance to, if you've taken some photographs today, #OmniAir Plugfest. And that's it. This is a wrap. Thank you, guys.